En los próximos 5 minutos vamos a dar comienzo a este webinario. Por favor, les pido unos minutitos para dar lugar a que la gente termine de conectarse. Muchas gracias. Bueno, muy buenos días a todos los presentes. Muchas gracias por esta participación. Este es un webinario organizado por la Embajada canadiense junto con la provincia de Ontario y AIDIS Argentina. Y su propósito es facilitar el vínculo comercial con el mercado argentino de las empresas canadienses que hoy van a exponer. Van a ser 6 empresas que van a exponer durante el día de hoy, tanto hacia los proveedores de productos, tanto como proveedores de productos o servicios, o como también con la posibilidad de alguna asociación con alguna empresa local que esté interesada. El otro propósito también es dar oportunidad de acceder a tecnologías a las empresas locales, a las firmas consultoras, a los prestadores del servicio, dar la posibilidad, decía, de acceder a las tecnologías de punta que puedan ayudar a las empresas a hacer un fortalecimiento del sector agua y saneamiento. Previo entonces a darle la palabra a las autoridades aquí presentes, les recordamos que esta presentación será grabada y también será traducida simultáneamente, para lo cual quienes no tengan el programa Zoom instalado en su computadora pueden descargarlo gratuitamente de esta aplicación. Ahí van a tener que cliquear el idioma que prefieren, ya sea el inglés o ya sea el español. Así, dicho estas primeras palabras iniciales de presentación de este webinario, quería darle lugar en primer término la palabra al ingeniero Christian Taylor, actual presidente de Aeration Argentina, es uno de los 3 organizadores de este evento. Seguidamente nos dirigirá la palabra el señor embajador de Canadá en Argentina y Paraguay, señor David Usher, y para finalizar esta presentación también le vamos a dar la palabra a la licenciada Claudia Peñalosa, directora para América Latina del Gobierno de Ontario. Así que, sin más, yo le cedo la palabra al ingeniero Christian Taylor. Le pido, por favor, que ya esté en pantalla, como ya lo vemos, para que inicie su presentación. Christian, por favor. Gracias.
Embajador de Canadá en Argentina, David Usher. Licenciada Claudia Peñalosa, directora de América Latina del Gobierno de Ontario. Empresas canadienses, representantes de la Cámara de Comercio argentino-canadiense, representantes de la Embajada, del Gobierno de Ontario, colegas y amigos. Bienvenidos a todos a este webinario de agua y saneamiento. Quiero agradecer especialmente a la Embajada de Canadá y a la Cámara de Comercio argentino-canadiense por su confianza en nuestra asociación para llevar adelante la organización de este webinario de intercambio técnico-comercial que es tan importante para nuestro país. Esta pandemia nos ha afectado a todos y nos sigue afectando. Se está viniendo la segunda ola. Nos ha permitido, a pesar de todas las cosas que están sucediendo, nos ha permitido, como puntos positivos, posicionar el tema de agua y saneamiento, ¿no?, en nuestros países, y en particular en Argentina, en primer lugar de la agenda pública. Por otro lado, hemos aprendido a utilizar estas herramientas virtuales que nos han ayudado a poder conectarnos mejor, intercambiar experiencias y tecnología entre distintos pueblos, en este caso entre Argentina y Canadá. Y por ese motivo, bueno, en Aeration Argentina estamos convencidos que estos intercambios son el camino para poder avanzar hacia soluciones innovadoras, que nos lleven hacia el camino del desarrollo sostenible, y en particular, en lo que se refiere a este webinario, la temática de agua y saneamiento. Desde nuestra asociación estamos desarrollando un sinnúmero de actividades, de webinarios, cursos, hemos desarrollado guías técnicas y buenas prácticas. Nos estamos fortaleciendo con distintas instituciones, adicionalmente a las embajadas, con otras instituciones internacionales, como por ejemplo con la WEF, la Water Environment Federation, que estamos trabajando con ellos. Estuve esta semana reunido con ellos. Recientemente, Aeration Argentina es el representante de Argentina en la Asamblea General International Water Association. Y así que estamos trabajando fuertemente, aparte de Aeration Interamericana, que es de toda América, con otras asociaciones internacionales para trabajar, en definitiva, para generar estos intercambios, ¿no? Para la mejora para el desarrollo sostenible de nuestros pueblos. Por otro lado, estamos organizando un congreso internacional en abril del 2021 de Agua, Saneamiento, Ambiente, Energías Renovables, así que los convocamos a todos a participar. Bueno, espero que este webinario sea beneficioso para el desarrollo del sector en Argentina de agua y saneamiento, y también, por supuesto, para que se presenten oportunidades para las empresas canadienses en nuestro país. Y también espero que pronto cese esta pandemia y podamos encontrarnos en forma presencial y compartir un nice wine junto a nuestros amigos canadienses. Así que bueno, disfruten este webinario. Gracias. Juan Martín, estás muteado.
Muchas gracias, ingeniero Christian Taylor, por tus palabras. Ahora sí vamos a dar paso a las palabras que seguramente nos dirigirá el señor embajador David Usher, el señor embajador de Canadá en la Argentina y en Paraguay. Esto es muy importante también dar a conocer, porque hay amigos paraguayos que se han inscrito en este webinario y es oportuno también que las palabras del señor embajador lleguen también a estas personas. Señor embajador, su palabra. Gracias.
Muchas gracias, Juan Martín, y buenos días. Es un gusto participar en este encuentro con el apoyo de AIDES Argentina, del Gobierno de la provincia de Ontario y de la Cámara de Comercio argentino-canadiense. Y muchas gracias a todos por sus esfuerzos y su compromiso para organizar este webinario acerca de una temática tan prioritaria para el Gobierno de Canadá, como lo es el desarrollo y la adopción de tecnologías limpias y la lucha contra el cambio climático. Quiero resaltar también que me complace muchísimo constatar el gran interés que ha generado el tema, no solo en Argentina, pero en toda la región, desde México, Panamá, Nicaragua, Colombia, Ecuador, Perú, Bolivia, Brasil, Paraguay y Chile. Agradezco que esta nueva modalidad virtual nos permita organizar este tipo de encuentros con un alcance regional. Y bienvenidos a todos. Al igual que la Argentina, Canadá es un país rico en recursos naturales que debe encontrar formas más limpias de producción para proteger el suelo, el aire y el agua. En Canadá, pensamos que proteger el medio ambiente y crecer económicamente no son objetivos incompatibles. Por eso, nuestro gobierno viene haciendo inversiones estratégicas en el desarrollo de tecnologías limpias, apoyando a empresas innovadoras a comercializar sus soluciones y mostrando el ejemplo al usarlas. Respaldadas por un ecosistema de innovación robusto, las tecnologías y soluciones desarrolladas en Canadá están solucionando algunos de los retos del sector de aguas en todo el mundo. Desde el transporte y distribución hasta el tratamiento y reutilización, las soluciones canadienses están cambiando drásticamente la forma como el mundo gestiona el agua y las aguas residuales. A medida que experimentamos el rápido crecimiento de las poblaciones urbanas y los impactos del cambio climático, las ciudades y empresas se enfrentan a una demanda creciente de agua limpia y potable, así como a graves amenazas a la seguridad del agua y los recursos hídricos. Por lo tanto, nunca había sido más urgente la necesidad de gestionar los recursos hídricos y las aguas residuales de manera inteligente, sostenible y eficiente en el uso de la energía. Los rápidos adelantos en sensores y equipos de monitoreo no solo han reducido sus costos de producción, haciendo estas tecnologías más accesibles y ampliamente disponibles, sino que están cambiando la forma como el mundo gestiona el agua y los riesgos potenciales. También, a medida que el mundo se mueve hacia una economía circular, se están desarrollando tecnologías y soluciones para recuperar valor de las aguas residuales, incluyendo energía y otros productos. Esta mañana nos acompañan especialistas de 6 empresas líderes canadienses que operan alrededor del mundo para presentar tecnologías y proyectos que optimizan el manejo de los recursos hídricos. Les doy la bienvenida y les agradezco a ellos también y les deseo a todos un muy interesante encuentro. Espero que en colaboración sigamos avanzando la agenda de del cuidado del medio ambiente en nuestros países. Muchas gracias a todos.
Muchas gracias, señor embajador, por sus palabras. Muchísimas gracias nuevamente, reiterando este deseo de tener un mundo más sostenible. Y ahora sí, para finalizar esta ronda de presentaciones, quería dar lugar a la licenciada Claudia Peñalosa, que ella es directora para América Latina del Gobierno de Ontario, quien también fue una de las organizadores de este evento. Le quiero ceder la palabra para que también le dirija al público. Por favor, Claudia.
Muchas gracias, Juan Martín, y muy buenos días para todos. Estoy muy contenta de estar participando en este webinario Agua y Saneamiento en colaboración con la Embajada de Canadá en Argentina, la Asociación de Ingeniería, Sanitaria y Ciencias del Ambiente, AIDIS Argentina, y la Cámara de Comercio Argentino-Canadiense. Como dijo Juan Martín, mi nombre es Claudia Peñalosa. Soy directora para Latinoamérica y el Caribe en el Ministerio de Desarrollo Económico, Creación de Empleo y Comercio de la provincia de Ontario. El aumento de las exportaciones y la diversificación de los mercados de exportación es fundamental para la competitividad y el crecimiento de las empresas medianas y pequeñas de Ontario, así como para la salud económica general y el crecimiento de la provincia. Nosotros, en el Ministerio, ofrecemos una serie de programas y servicios que promueven los intereses económicos de Ontario en mercados claves, al facilitar el acceso a los mercados globales y a ayudar a las empresas de Ontario a exportar. Dentro de estos programas se encuentran la organización de webinarios y misiones comerciales que originalmente las hacíamos en persona, ahora las hacemos virtuales por el momento, donde promovemos interacciones con prospectos precalificados, incluidos potenciales compradores, distribuidores, potenciales socios y potenciales inversionistas. Ontario sobresale en lo que respecta a la tecnología del agua. Nuestra provincia tiene mucha agua dulce, más de 250,000 lagos, 100,000 kilómetros de ríos y los grandes lagos que contienen el 20% del suministro de agua dulce del mundo. Con esta abundancia, nuestra provincia ha desarrollado tecnología vital para abordar las necesidades de agua, lo que nos convierte en un líder mundial en innovación. Ontario es lo que se puede llamar el Silicon Valley de la tecnología del agua. Es un centro mundial de investigación e innovación en tecnología del agua. Muchos de los avances más importantes provienen de Ontario. De hecho, aquí se desarrollaron 2 de las tecnologías más utilizadas, la desinfección por rayos UV y la filtración por membrana. En Ontario hay más de 900 empresas de tecnología del agua, más de 100 institutos de investigación y más de 22,000 personas altamente calificadas que trabajan en el sector de tecnología de Ontario. Las tecnologías que les presentarán hoy estas 6 compañías de Ontario son parte de este gran universo que buscan desarrollar vínculos comerciales en Argentina y Latinoamérica. Muchas gracias.
Muchas gracias, Claudia, por tus palabras y justamente las palabras estas que refuerzan lo que nosotros decíamos al principio, esta idea del webinario de tener estrechar los vínculos comerciales entre empresas canadienses y empresas locales y a su vez permitirle a las empresas locales, al público asistente, al público interesado en general, acceder a estas tecnologías de punta. Y bueno, justamente a partir del desarrollo de este webinario en los próximos minutos, vamos a poder tener acceso a alguna de estas tecnologías. El webinario se ha pensado en dos grandes bloques, un primer bloque de 3 empresas que nos hablarán sobre calidad de aguas y monitoreo en general, y un segundo bloque de 3 empresas también que nos hablarán sobre recuperación de recursos e inteligencia artificial. Pero previo a dar la palabra a la primera de las empresas, me gustaría dejar algunas indicaciones justamente para que cada uno de nosotros tengamos en claro qué es lo que vamos a presenciar en el día de hoy. Cada una de las presentaciones tendrá un espacio de unos 30 minutos, de los cuales habrá los primeros 20 minutos. Los presentadores disertarán, expondrán sus productos, sus servicios, sus tecnologías, y se deja un espacio de aproximadamente 10 minutos para efectuar las preguntas que que el público quiera hacer. Para ello deberán formularse las preguntas no en el chat, sino en la sentencia que dice Q&A, o sea, Question and Answers, o sea, preguntas y respuestas. Ustedes lo van a ver al pie de la pantalla de su computadora. Van a ver entonces el iconito como para acceder a las preguntas desde allí. Por favor, les pido que esas preguntas entonces se formulen desde allí. Allí nuestro compañero de AIDIS Argentina, Jorge Durán, las recogerá, las compilará y podrá formular las preguntas a cada uno de los oradores. Obviamente, en el caso de que las preguntas y sus respuestas excedan los 10 minutos que tenemos previsto, y para no atrasar al resto de los oradores, de los disertantes, el resto de las preguntas que no hayan podido formularse en ese tiempo se podrán responder luego por escrito, de modo que en todos los casos cada uno de los interesados tendrá su correspondiente respuesta. Finalmente, les vamos a informar a los participantes que los que estén interesados en establecer un vínculo comercial con alguna de las empresas que hoy van a exponer, nos deberán enviar un correo electrónico a la siguiente dirección. No es enviándole a las empresas la consulta o su interés, sino canalizándola a través de AIDIS Argentina. El correo electrónico es secretaría@aidisar.org.ar. Lo repito, secretaría@aidisar, todo junto, .org.ar. Dirigiendo entonces el correo electrónico, manifestando su interés, se van a coordinar las entrevistas privadas, individuales, que se desarrollarán con las empresas estas y obviamente con la intersección de la Embajada, de la representación de la Embajada de Canadá, durante la última semana de noviembre. No sé si ustedes están viendo ahora en pantalla cuál sería entonces la agenda, ¿sí? La agenda prevista de las 3 primeras empresas y luego las otras 3 empresas que se van a exponer durante el día de hoy. Así que reitero, el tema es las preguntas que no puedan volver a formularse o que no puedan responderse por falta de tiempo, serán respondidas en forma escrita a posteriori. Por otro lado, como decía yo al principio, para quienes no pudieron participar del inicio, esta está siendo grabada, todo este webinario está siendo grabado, con lo cual luego va a ser publicado en las redes sociales, tanto de la Embajada de Canadá como de las redes sociales que tiene Aeration Argentina, de modo que a partir de los próximos días, toda esta versión ustedes la van a tener también disponible, así que siéntanse en libertad también de acceder a ella. Ahora sí, entonces, vamos a ir preparándonos para dar paso a la primera de las presentaciones, ¿sí? Que estará a cargo de la firma Realtech. La firma Realtech que abordará el tema medición de calidad de agua en tiempo real. Para ello están los señores Drew Evans, que ya lo veo en pantalla, y Kerim Kolu, que nos van a exponer justamente en ese orden. El señor Drew Evans es vicepresidente de Desarrollo de Negocios y Relaciones Gubernamentales, con casi 20 años de experiencia en ventas y gestión. Drew ha sido fundamental en el crecimiento de la presencia internacional de Realtech y en el desarrollo de asociaciones estratégicas clave que se han contribuido al crecimiento de la compañía en más de 50 países en todo el mundo. Tal como lo había mencionado el señor embajador, la mayoría de estas empresas, me permito yo de reiterar, son empresas internacionales que operan en muchos países del mundo, de modo que ahí tenemos una buena oportunidad también de acceder a sus conocimientos. Por otro lado, también va a exponer el ingeniero Kerim Kolu, que es el jefe de aplicaciones, tiene más de 13 años de experiencia en la investigación, en procesos de tratamiento de agua y uso de herramientas en línea para la optimización de procesos utilizando datos de calidad de agua en tiempo real. Él trabaja también en el desarrollo de aplicaciones para sensores de monitoreo de calidad de agua en línea. Yo les pido que entiendan, estoy tratando de hablar un poco más lento justamente para permitir que las traductoras, las intérpretes puedan desarrollar más eficazmente su trabajo. Así que, sin más palabras, yo le doy lugar al señor Drew Evans para que dé comienzo a su explicación. Mr. Drew, please.
Fantastic. Thank you so much. And good morning, everyone. It's an absolute pleasure to be able to speak with you today. Kerim and I are very pleased to be able to share some of our experiences that we have been able to capture and learn from over the last many years. So anyway, again, as was mentioned by Juan, my name is Drew Evans, and I'm the VP of Business Development in Government Relations for Realtech. And my colleague Kerim Kolu is the Chief Application Scientist.
Good morning, everyone.
Great. So today the agenda is to give a quick overview of Realtech and who we are, where we've come from. And then Kerim will focus more on the technology and application section, with the focus being on real-time nitrate monitoring, as that seems to be quite an issue in Argentina, as well as talking about organics monitoring, as this is something that is increasingly becoming a greater issue. And again, we'll expand further on this shortly. Great. Well, as was mentioned, we have clients and customers in over 50 plus countries across the globe. We've been very honored to work with some of the biggest and brightest and amazing companies, and I'll talk about some of them in a moment shortly. We are a Canadian company, we're privately held, and we continue to work towards our goal of trying to make real-time water quality monitoring accessible to everyone. The reality is that with taking grab samples, we're not always fully capturing the full picture of what's going on, and real-time information gives us that ability to be able to do so. As you're seeing on the map here, we have some significant sales in many different geographic regions, as it's quite impressive to see the varying degrees that some countries are going to. Within Asia, there's been an adoption of real-time water quality monitoring, with COD, BOD real-time monitoring becoming regulatory requirements in countries like India, Indonesia, Vietnam. And we only expect this will continue to happen further as these type of solutions become more and more accessible. Next. We've been honored to work with some of the largest and some of the biggest companies in the water sector, as well as across the globe, working with some of the biggest bottling companies in many different geographic regions, working with some of the larger water players with Xylem, as we do support them with our real-time UVT, UV254 solutions. NASA has even bought a portable meter for some testing, so we're very honored of that. A couple other ones that I will just briefly point out. In the bottom left corner is a logo for a company called utility called Irish Water. And Kieran will talk further about them, but we have over 330 plus sensor installations across all of Ireland, having one of the largest footprints. Finally, we have worked with the US EPA, and actually back in 2009, 2010, had the honor of them evaluating our UV254 solution. And they produced a 40-page report as our solution did better than the competition, as we had faster detection capabilities, faster response times, and we could detect at lower concentrations. Next slide. So the great thing is that we have a solution for many, many different parameters. So I'll note a couple of them here. So TOC or COT, BOD, DBO, COD, DQO, nitrates, nitrites, lots of different parameters. So please do have a look, or if you do have any questions whether we can detect that in real time, please do reach out to Juan and his team, and we'd be happy to discuss and explore further with you. Next. Next.
Drew, we're at the next.
I don't see the slide changing here, but hopefully you can see the next one, where basically what we have is we can build solution packages for you, from wastewater to high purity applications. We have a number of different solutions with different path lengths. So we have ones that can handle, the dirtiest of Hello? I believe we had some technical difficulties there. My apologies. I'm not quite sure where we left off, but anyway, just to reiterate, we have solutions for wastewater to high purity, as we can use many different path lengths to be able to handle different types of water sources. So what we typically will do is we will build a bundle package together for a customer, where we'll take one of our couple of different controller options, as well as what other real-time parameter and sensors you would need. We can complement that with some additional third-party parameters like pH, conductivity, ammonia, DO, and then add in accessories to be able to make this application feasible, whether we use chemical cleaning to automate the cleaning process, pump in cleaning systems to draw samples, and we have a number of other features that I don't have enough time to get into, as well as data services from creating custom algorithms for a customer specific application in site. So it's dialed in specifically for that type of parameter. Or we can have cloud-based monitoring solutions where you can access your information from anywhere. So, and again, not enough time to really go into details, and I'd like to pass along over to my colleague Karen to continue the discussion. My apologies with the technical challenges, as I believe I had some internet issues. Gracias.
Right. Thank you, Drew. I hope everybody can see the slides because I've been changing them, but Drew wasn't seeing it, so I hope everything's working fine. So I'll first talk a little bit about our technology, just so to introduce the technology to you at the basic level. And we start with how we measure. So at the core of Realtek is a really simple principle. It's that when you shine light through water, some of that light gets absorbed. And according to Beer-Lambert law, that absorbance is directly related to the concentration of compounds present in the water. So the more of a compound you have, the higher the concentration, the more it will absorb light. However, when you have a lot of compounds in the water, their absorbances keep getting add up. And of course, that makes things less simple in the real life, as we always have more than one compound. So how we measure is essentially, we look at light through many wavelengths, starting at 190 nanometers and scanning the wavelengths all the way to 750 nanometers. And that helps us essentially rebuild that absorbances that have been added up. So because they're added up, we see a very generic absorption curve, the one such as the one you're seeing here. But we are able to reconstruct the individual absorbances looking at multiple wavelengths. For instance, in the higher wavelengths, we usually see solids absorbing. Actually, solids absorb all across the spectrum. But because at the higher wavelengths only solids absorb, we are able to use that region of the spectrum to relate to the presence of solids. And if you look at different regions of the spectrum, as you can see on this figure, you can see that in the very short wavelengths, we can detect nitrite and nitrate. And in the other 200 wavelengths, we can detect organic parameters, such as the ones, as Drew mentioned as well, total organic carbon, chemical oxygen demand, or biochemical oxygen demand. We also detect many other parameters that absorb that are not present on this figure, but we can touch on them later on if there's any interest. So one thing about using light technologies is that light sources produce light in a fluctuating way. So essentially the light fluctuates a lot during the real-time operation, and that has to be compensated for. And Realtek has some innovative ways to deal with this, such as we have patented and proprietary technologies to overcome this problem. And also we use different light sources. As you can see on the figure on the left, you can use deuterium lamps, which are very expensive, but at the same time, they're very, very accurate because they're very stable light sources. Or you can use, for instance, xenon flash lamps, which are less accurate, but also cheaper. Now, I mentioned this because this is really important. When we talk about real-time monitoring, it's actually really important to realize what the goals of the end user are. You might be looking for something that gives you trending information that helps you with real-time process control. And therefore, you may not need a very, very high accuracy. The importance of that, again, as I mentioned, is that your solution that works for you does not need to be expensive. If you need accuracy, then you might want to spend a little bit more money and get a more expensive solution that's more accurate, which will also require more maintenance. But if your goals are more about process control or simple trending, then you might want to opt for a lower accuracy, but also lower maintenance and a lower cost solution. Now, after this point, I'm going to talk about some of the applications where our products are used. Just to give examples, we'll go over some parameters and case studies and how our solutions have been put into work. And we'll start with groundwater nitrate monitoring. All right, so nitrate, as I'm sure most of you know, is the regulated water quality parameter. It's usually limited to 10 milligrams per liter nitrate as nitrogen, or according to WHO, it's 50 milligrams per liter nitrate. But of course, these are actually very similar concentrations. It's just a different way to express the same concentration. So usually we're looking at about the same regulatory limit across the world. Real-time detection is important because it helps you identify changes in the water source right away, within seconds. Whereas if you were to analyze those samples in the laboratory, there will be a delay in getting the results. Now, what's the importance of detecting the concentration in real time is mostly about process control. Some of the key applications in drinking water where we see real-time nitrate monitoring to be really beneficial are blending, where there's multiple wells where the water is provided to the utility, and some of those wells have high concentration of nitrate, and some of those wells have lower concentrations of nitrate. If the blending can be done efficiently, then there would be no problem of exceeding the regulations, and the water can be used more efficiently across the wells. Another issue where we see a lot of benefit is treatment processes such as ion exchange, here denoted as IX, or reverse osmosis, RO. So these treatment processes are very effective, but they're usually very expensive to operate because there's operational costs associated with them. And the longer their lifetime, of course, the lower these costs would be because they're related to regenerating the systems and also disposal of some of the waste. Therefore, if real-time monitoring can be integrated into the treatment system, then it's possible to more effectively operate these treatment systems and get more out of them in the long term. So I will actually explain this a little bit better on the schematic. As I mentioned, there's multiple monitoring options. We'll start with number 1. So we can monitor individual wells so that we will know exactly what the nitrate concentration is in a well. Or we can go for a more simpler blending point where we look at the blended water at number 2, and therefore we know after blending what the nitrate concentration is. The similar idea applies to the treatment system. If you have a treatment system, you might want to monitor right after the treatment system, or you might want to look at the blended water where some of the water is bypassed, essentially to make sure that the treatment system is not overwhelmed and it operates for a longer time in between regenerations. But as long as you're monitoring at 0.4 and making sure that those two blended together still meet the regulations, you'll be in safe operation mode. Now I'll move on to a case study. As I mentioned, we see a lot of use for this in groundwater monitoring, but anywhere you see nitrate, of course, there might be a value for nitrate monitoring. But this example is from a groundwater utility in Suffolk County in New York State. And this is a groundwater utility where there's multiple well stations, and each well station, as you can see in the figure here, might have multiple wells. And as I mentioned, this fits into the case scenario where they have contaminated wells and wells that don't have a lot of nitrates. So the strategy the utility utilizes is to combine water from wells that have a higher concentration of nitrate with wells that have a lower concentration of nitrate, making sure that what's being given to the consumers is safe to drink. This utility actually tried our solution against a competitor brand, and I really want to show this because there's something important here. As much as the accuracy of sensors is very important, there's other things that accompany a sensor that are also very important. And here, I'll explain the figures a little bit first. So what we see here is the nitrate concentration in real time over a week. And the spikes you see, for instance, the one here, is when a high concentration nitrate well starts pumping into the system. So both systems are very accurate. They detect these spikes, and therefore the utility is able to manage how their water is blended. However, the important thing here is that, as you can see on the graph on the right side, over time we see a drift up. And this is what I meant when I said accuracy is important, but there's other factors. Because these sensors are real time, their cleaning is also very important. And a lot of sensor companies would provide their sensors with an automatic cleaning system. But it's very important that those cleaning systems closely match the type of water that their sensor is being used for so that they can work effectively. Now, the main difference between the two sensors wasn't that they were not accurate given ideal conditions, but that Realtek's sensor was accompanied with the right cleaning solution so that it can run free of drifting and fouling over a very long time, so that the utility staff didn't have to visit the site and do a manual calibration or a manual clean, which was, for a rural utility, it was actually a lot of work because a lot of these well stations are not manned 24 hours a day, and therefore it's an important aspect. So my point here is that, you know, it starts with the sensor and how accurate it is, but there's other factors that play into it as soon as we talk about real-time monitoring, and those are not to be taken lightly because they can be actually making something reliable versus not reliable. Next, I'm going to talk about some surface water monitoring applications where we will focus on organics this time. So when we talk about organics, of course, it can be represented by different aggregate parameters, such as we would be looking at total organic carbon, or we can look at chemical oxygen demand, etc. But the important thing here is that when we talk about organics, most organics absorb light, and therefore they can be measured using the UV absorbance technology. And of course, same as in nitrates, the benefit of real-time detection is that there is no time delay where you have to wait for laboratory testing. In surface water treatment plants, where we see the biggest benefit in our customers is that the feed-forward control information that's provided when you monitor your source water in real time really helps with the coagulation process, where solids as well as some of the organics are removed from the process, and how much coagulant is added heavily depends on the presence of both solids and organics. If you look at the figure here on the right-hand side, this is data from one of our clients, and you can see just how quickly the water can deteriorate in terms of its organic content. But this site had real-time monitoring, and their treated water didn't get affected at all. But the raw water quickly dropped within 3 hours following a storm because their water quality deteriorated. Now, monitoring organics also has further implications for the water treatment plant. Of course, if the organics are removed better, then disinfection byproducts are going to be less because their precursor is organics. And of course, it gives a peace of mind for compliance in public health and safety. One of the options in real-time monitoring for organics is TOC analyzers, which again can be very accurate, but they tend to be expensive and there's operational cost involved. Whereas while optical methods such as UV absorbance is reagent-free, these TOC analyzers usually have consumables that are associated with them. I will continue with a case study, and this is actually not one site, but over 300 installations. We've been present in Ireland, and there's been more than 300 installations because we've had a very high level of success with them. Irish Water uses Realtek's UV254 solution for organics monitoring in their source water, and they use this information as a feed-forward control for their coagulation process. In plants where they have UV disinfection, that also helps with their UV disinfection systems, and also goes without saying that it also helps them with their disinfection byproducts compliance. One thing about Ireland, of course, is that their source water is very prone to high level of organics, and they can change rapidly, and therefore the benefits are very important to the utility. I will continue with some examples from municipal wastewater, where we'll also look at BOD and COD. So it's still organics monitoring, but we'll approach it from a different perspective. So organics monitoring is really at the core of it is that there's different groups of organics, and these aggregate parameters such as TOC, BOD, or COD, they can all relate to these organics. And UV absorbing organics are also related to these organics. The important thing is that there's a very big overlap between these different approaches, and therefore a lot of the time they can be used in place of one another. When we look at BOD monitoring for wastewater treatment plants, I think it's really important to mention that because biochemical oxygen demands a 5 to 7 day test, it has pretty much no process control value. Whereas if you do it in real time, you'll be able to really implement the corrective action as soon as you get the data. Now, here we're looking at, again, real-time data from one of our customers. And this is over the course of 2 days. We're looking at BOD. As you can see, the gray line is the real-time BOD fluctuation verified with laboratory BOD data at several points. The importance of this graph is that if the utility was to look at the average BOD, all they will have is 200 milligrams per liter average BOD. Now, this is useful information, but only to an extent. As you can see, throughout the day, the BOD goes much lower and much higher, and therefore there's much that can be done with the process control. One example of how the process can be controlled is where we see a lot of pain point in smaller wastewater treatment plants, where a sudden spike in the organic load coming in can really cause trouble with the aerobic system, the biological treatment system. The way smaller wastewater treatment plants deal with this is by boosting chemically enhanced sedimentation, which increases the BOD removal. And how much chemical is added is closely tied to the level of organics that are coming in. And therefore, with real-time monitoring, it's very easy to optimize how much chemical to add. This is just a schematic showing where the monitoring can be. We usually see the biggest value in monitoring the influent, the incoming wastewater to the treatment plant, because the earlier you get the information, the more you can do with it. And I'll give some another example to this. It's just that even if you're not looking at BOD, we can detect events that in the incoming wastewater. And by this, what I mean is that because these sensors are real-time monitoring sensors, over time they learn the water. And the more they're installed, the more they know about the water. And therefore, they're able to tell you what is a normal fluctuation and what is an anomaly. When you have a spike that's different than all the other spikes that happened before. And working through this data, we're able to tell our end users when these events happen, what kind of events happen, which can be very valuable information as well. And to that account, I'm going to give 2 quick examples before wrapping up this presentation from industrial wastewater monitoring. The first one is actually very straightforward. We see this a lot in the food and beverage industry. The example here is from a dairy manufacturer. A lot of the times, the high level of organics in their wastewater is a direct result of spill events or some sort of leak that they're not aware of. And therefore, by real-time monitoring, it's possible to find a quick solution to this problem and make sure that it doesn't happen anymore. And therefore, the product doesn't end up in the wastewater. Now, this is really important because product is valuable to the manufacturer as is. And when it ends up in the wastewater, it's also a treatment cost that's added. And if the manufacturer is discharging its wastewater to the city sewer system, then they also have to pay a surcharge for their high load of organics. So this is a really win-win situation for the manufacturer. And as this example demonstrates, we see a lot of benefit here where they were able to quickly realize a spill event that was happening right after the installation of our monitoring system, and we're able to take corrective actions for that. My last example is from the pulp and paper industry, where we're looking at event detection. This is actually a Post-it plant where they use different dyes to color their paper products. And therefore, they were not just interested in BOD or color, but they were interested in specific dye concentrations, which you can see on the figure here. It's different colors of dyes. And also some events that are specific to the industry that were happening. These are, again, spill events that happen in the pulp and paper industry, such as black liquor, foul condensate. So it's, the approach here is a very multidimensional approach. We don't look at just one parameter because BOD tells you the sum of organics, yes, but there might be other things happening with your process, and it's possible to monitor that using UV visible spectrum absorption. With that, I'll conclude this presentation. Thank you very much for your attention. And if you have any questions, both Drew and I'll be very happy to answer them.
Thanks, Kerem.
Muchas gracias, Drew. Muchas gracias, Kerim. Vamos a dar paso a algunas preguntas que veo que se han formulado. El ingeniero Jorge Durán, que está en mi colega, va a recolectar las preguntas y se la va a formular justamente a cada uno de los panelistas. Adelante, Jorge, si podés resumir algunas de las preguntas que se hicieron, y reitero, no lo hagan a través del chat, sino a través de la opción QIA. Por favor, muchas gracias. Jorge.
Gracias, Juan. La primera pregunta es si existe alternativas de medición para surfactantes?
I'll take that question. Yes, there are. We've been actually, if I go back to maybe the slide where we're showing some of the parameters that we monitor, you would be able to see surfactants here. We've been involved in surfactant applications. It is possible to monitor them. However, it depends on the type of the surfactants as well. The group of surfactants that our technology is best suited for is anionic surfactants.
Perfecto, muchas gracias. La segunda sería, se mencionó que se podían medir pesticidas. ¿Qué compuestos se podrían estar midiendo y qué familia de pesticidas se podrían detectar?
The family of pesticides that can be detected, that's actually a bit of a detailed question. Maybe I can get back to the person who asked the question in written form. The pesticides that we've worked with, one of them is aldicarb that I remember. This was a joint project we did with an Israeli water utility. And there are different groups they looked at, but I'll be able to better address this question in written form because I don't remember the groups off the top of my head, but I'll definitely be able to get back to you in written communication.
Perfecto. La siguiente es si han suministrado este tipo de sistema para inyección de agua o sistema EOR en la industria de gas y petróleo. ¿Han trabajado en la industria de gas y petróleo?
To my knowledge, we did not get involved in the direct application of EOR systems. However, we've been involved with the oil and gas industry, but not that particular application to my knowledge.
For enhanced oil recovery, it is indicating.
Perfecto. Muy bien. Y la última que tengo por acá es si pueden mencionar, creo que lo hicieron, pero si pueden destacar algún proyecto con el sector agrícola.
With the agricultural section, I believe like we've been in nitrate monitoring projects with them as well, but it's more the hydroponic type agricultural facilities, not like the traditional agricultural systems. Usually we work with water utilities that are affected by the agricultural industry. However, if there's water and their water has any of the parameters we can monitor, we will definitely be able to help them.
Y creo que entre las últimas que están llegando es si tienen alguna opción para medición de arsénico.
Unfortunately not. We get asked about arsenic quite a lot, but unfortunately we're not able to do that.
Bueno, y dentro de las últimas acá, pregunta si se puede mostrar un ejemplo de instalación de un paquete de sensores en una corriente de salida de efluentes cloacal típica.
I believe I don't have it in this presentation. However, Drew, do you have something you can share on the screen or?
Probably not quickly enough.
Okay. Let me see. Oh, actually, I might have, sorry, I apologize. I do have a picture where in one of the slides, I think I saw it.
Tenemos un minuto solamente, por favor, Drew. Gracias.
Okay. I believe this is not the best picture, but this is an example in a water utility, drinking water utility, where it's the sensor is fixed on a backboard, as you can see here. And this is the cleaning system, and this is the sensor. These are bypass style sensors, so the water is pumped through the sensor. But we have different form factors. Of course, we can provide more information and more pictures on any of these. It's not part of this presentation. I apologize for that, but we can provide the information.
Definitely, we would be happy to meet and discuss with anyone who would like to learn more about real tech. And we are looking to continue to expand our presence in South America. So please, for Argentina as well as other markets, we do have some partners in some specific regions, but always happy to discuss further and see what kind of real-time monitoring needs you might need. So thanks again, everyone.
Yeah, thank you, everyone.
Muchas
Bueno,
gracias.
muchas gracias, Drew. Muchas gracias, Kerim. Ha sido muy clara su exposición. Por supuesto, como bien decía recién Kerim, cualquiera que necesite tener alguna información lo tiene que canalizar, por favor, a través de un correo electrónico a secretaria@aidisar.org.ar. Entonces, ahora sí le vamos a pedir la palabra a Ryan Howard, que nos va a mostrar el único equipo automático aprobado por la EPA de Estados Unidos para test rápido in situ de calidad microbiológica de aguas. Ryan es director de ventas y desarrollo de negocios de la compañía Tecta PDS, con más de 25 años de experiencia en distribución y marketing, trayendo innovaciones de productos de nueva tecnología al mercado internacional de las industrias del agua, la electricidad, gas natural y telecomunicaciones. En los últimos años ha impulsado la promoción del sistema Tecta B16, que seguramente nos va a mostrar, la única solución rápida entonces para las pruebas de calidad de agua microbiológica in situ automatizada del mundo. Entonces le dejamos la palabra, por favor, a Ryan. Adelante, Ryan, por favor. Gracias.
Thank you very much. I'm very excited to be here today and excited to introduce to the Latin America marketplace a very innovative solution to microbiological water quality testing. The product that I'd like to introduce you to is called the Tecta B16. To repeat what she just said is we are the world's only US EPA approved, fully automated, rapid results on-site microbiological water testing system. A little bit of company history. Tecta was developed in response to a water contamination event that happened in Canada back in the year 2000, where well water got contaminated the town's drinking water system. That town is roughly 5,000 people. 2,300 people got sick and 7 people died. As a result of that event, there was a government investigation into the root cause of why that happened. And they had reached out to academia across the world and leading researchers to come up with a solution to preventing an event like that from ever happening again anywhere in the world. The root cause that was identified was the way we test water. And there was a lot of inadequacies. There hasn't been a lot of new innovation in this area. In the year 2003 at Queen's University, under the lead direction of Dr. Stephen Brown, the first prototype of the world's first automated solution for water testing was developed. And one of the largest companies in the world, Veolia, ended up buying the technology and refining it, commercializing it, getting the US EPA approval. And they built a global water platform, leveraging that technology for the water plants that they build and manage. There was a restructuring at Veolia in 2016. They divested of new technologies such as Tecta, And the technology was sold back to the inventing team, and it is back in Canada now. And we are now a privately owned company and fully, all of our operations is now centralized in Kingston, Ontario, Canada. Toc Systems, we have hundreds of customers globally in over 40 countries worldwide across multiple industries and applications. I'm excited to be here today to introduce our product into Latin America and the Caribbean. Really, this is our first foray into the region. We've had so much success globally that we felt it was time. To understand our technology, it's important to understand some of the basic challenges, problems that are faced by laboratories across the world and the most common methods used for water quality testing. The laboratories right now, especially with COVID, are very stretched in terms of having limited resources and are processing a lot of COVID tests. And so sometimes water quality has taken a back seat, and this is creating a problem in the industry. With the lab methods that are used, there's two common methods that are predominant in the world. The first one is membrane filtration, which is a culture-based method. Roughly 25% of the world is still using this method for water quality testing. It was invented in 1950. It requires a certified lab technician. The test needs to be done in a lab. It's a very time-consuming test. It relies on a fixed incubation time. And it is a very subjective test because it's based on counting, to make this simple, bugs on a plate through a microscope. As you can see, this is what some of the plates look like.
Perdón, Ryan, acérquese un poco más al micrófono porque está muy lejos y no se oye bien lo que usted está hablando. Por favor, gracias.
Can you hear me now? Are you able to hear me better? Can someone please confirm?
Sí,
Yes, we can
sí,
hear
se
you,
oye
Ryan.
mucho
Okay.
mejor. Se oye mucho mejor.
Okay. So as you can see on these incubated plates of membrane filtration, how difficult it could be to count the bacteria that has grown on the plates. When there is high concentrations of bacteria, typically what happens is plates get overgrown, and it's very subjective and difficult to count. The next latest innovation with the technologies used for water testing is what we call Enzyme Substrate. It's also a culture-based method. IDEX is a multi-billion-dollar corporation. They are an animal vaccine and pharmaceuticals manufacturer. But Dr. Colin Thicker at IDEX invented a product called ColiAlert. It is a test that is really a step up from membrane filtration, where you are incubating samples, and what's happening is that for coliforms, after incubation, if there is presence, the samples turn a yellowish color, and for E. coli, you're looking for a fluorescent change. And what IDEX provides is a comparator bottle. And so what's happening is you're pulling your samples out of an incubator, and you're making a visual judgment call as to whether or not it's greater than or less than the comparator. Sometimes water samples can be turbid and have color, which makes this testing method sometimes challenging. It also relies on being done in a laboratory environment by a certified lab technician, and requires a fixed incubation time. To do quantification, you need more equipment, and it requires additional steps and time. Again, IDEX has the leading technology for this, which is called QuadraTray or QuadraTray 2000. Again, it's reliant on a visual interpretation, a lot of steps involved, and it's prone to human error. Visual detection, I wanted to point out, can be very misleading. What we're trying to demonstrate here is that each of these, if you're looking for a color change, can be a bit tricky. Every single one of these vials are actually contaminated with E. coli. But if you were just to look at these and you were looking for a fluorescent color change, you might falsely claim that these two are not positive. The same with these. The other big challenge with the micromethods in today is the time to turn around test results. So there's obviously a process that's involved in terms of prepping, doing the incubation, the analysis, and communicating the results. In some cases, you need to ship samples to a third-party lab or to an internal lab. And this process can take anywhere from 1 to 5 days. The deaths that happened in Walkerton in Canada were a direct result of the time delay in getting the test results back because they didn't know the water was contaminated. And as such, they were unable to issue a public warning or a boil water advisory. There is a better way. And so TECTA set out to revolutionize the way that we test water. And so we've developed the world's first fully automated system to do this. It is a far simpler testing process. The solution is simply a benchtop unit that's portable. It contains incubation chambers. We provide an all-in-one test cartridge, which contains the reagent and some software. I'm about to show you a video, which gives you a tour of the TECTA B16.
The TECTA B16 has a power switch located on the right rear of the instrument. On both sides of the instrument, plugs can be removed to externally sample the temperature of the 4 incubation mantles. On the left rear of the instrument, there is an external USB port that can be used for connecting peripherals such as keyboard, mice, and barcode scanners. An Ethernet port is located above the USB port for network connectivity. On the front left bezel of the instrument, there is a second USB port. This can be used for the same peripherals and is convenient for connecting USB thumb drives. The TECTA B16 is equipped with a 7-inch touchscreen that can be operated with bare hands, a stylus, or gloved hands. Opening the instrument, the TECTA B16 has 16 incubation chambers. They are divided into 4 thermally controlled incubation quadrants. Then opening the service lid reveals the TECTA B16 optical system and how the optical probes self-align to the cartridge. It also reveals the simplicity of the unit for maintenance. The B16 can easily be maintained by ensuring optical plates are clean, and if the plates themselves become compromised, they can easily be replaced. The overview screen shows the status of the 16 chambers. On the icon bar on the left, you can either add a new test or you can review information from previous tests. Or we can go to the Home menu where you can change system preferences. For example, you can set the language preference. You can set the time, you can set your network information, or you can set customized email preferences. Many other customized preferences are available. For more information on the TECTA B.
And here's another video on how simple it is to conduct a test. Anyone, anywhere, at any time can operate a TECTA system.
To start, if needed, write sample information on sticker provided or add a barcode label. Open the sterile cartridge by placing thumb on locking nub and pulling the tab up until locked seal snaps off. Then place the cartridge on a solid surface, place 2 fingers under the lid finger tabs, and pull in an upwards motion. If sampling a tap, place the cartridge at a slight angle with the front of the cartridge facing the water flow and fill up to the 100 milliliter mark. When cartridge is filled, keep on an angle and tap a few times to ensure no water has accumulated in the lip of the lid. Place the cartridge on a flat surface, place the tab into the locking tamper-proof closure, then press securely around the lid, ensuring a watertight seal. Take a dry cloth and wipe the outside of the cartridge and ensure no moisture is on it. Inspect the bottom of the cartridge to make sure the polymer sensor is clean and moisture-free. Ensure all media is fully dissolved by gently swirling the cartridge for 30 seconds. Let sit for another 30 seconds and gently swirl again. Do not shake or bang the cartridge down at any time, as it could damage the polymer nub on the bottom and/or create bubbles, which could affect the test. Go to the Add Test icon. Add the sample information into the TECTA by either using a barcode reader or manually inputting the sample ID. Once sample ID is added, hit Add, and then go to the Overview icon. You will notice the chamber to be used is blinking amber on the touchscreen. Open the lid, place cartridge with the front facing out. Close the lid, wait for the blue progress bar to complete scan of the unit. The test will begin automatically once this has been completed. Once test is started, icons turn solid gray. At this time, one can click on any gray icon to enter additional comments or information. As soon as target bacteria has been detected, chamber icon will turn red. If absent for target bacteria after full incubation time has elapsed, the icon will turn green. Click on colored icon to review completed report. Alerts and completed reports can be sent via email to anyone, anywhere, in real time. For more information on the TECTA B16.
Oops. So what is unique about TECTA and what enables the automated process is our unique test cartridges. They are an all-in-one test cartridge that contains a special polymer nub at the base, which enables the automated test process. Each cartridge comes sterile, and it already contains the reagent in the cartridge plus thiosulfate if it's a drinking water sample to neutralize chlorine, which minimalizes heterotrophic interference. Again, to conduct a test, you simply fill up to 100 mil mark, swirl for 2 minutes, then add it into one of the 16 test chambers. But what's really key here is this special nub at the base of the cartridge. How the technology actually works is we are a similar method to IDEX. Our method is an enzyme substrate method. If you were to look at the US EPA approval, we are listed directly below IDEX, quality alert. And what we're doing is we're identifying a fluorescent enzyme. So as the targeted bacteria, such as E. coli or total coliforms, begin to multiply during incubation, they emit a special enzyme that interacts with the proprietary chemical substrate in the test cartridge, which releases fluorescent molecules from the substrate. What differentiates us from IDEX and what Dr. Stephen Brown discovered is that the fluorescent molecules are hydrophobic, meaning they're looking for a way out of the water, and they are absorbed into the base of the cartridge into the polymer nub. The polymer nub sits inside the unit on top of a UV spectrometer and an optical sensor that is scanning the cartridge real time while that test cartridge is incubating, which is eliminating visual interpretation. The entire optical path inside the polymer and optical fiber is contained. So what's happening here is that we're able to eliminate interferences such as turbidity and color and other fluorescent interferences that are prevalent in high levels of bacteria. Now, high levels of bacteria can return test results in as little as 2 hours, with lower levels taking longer. A no presence result is returned after 16 to 18 hours, depending on the test type. If E. coli and total coliforms is detected, an email will be instantly sent at the time of detection. The alert email will include the full report, which is automatically generated and can be sent to anyone, anywhere, at any time. The reports are hard written onto the device. They can be accessed through a thumb drive, but they can't be changed, which adds integrity to the testing process. It includes all the detailed information that you enter at the time of the test. Plus, we're reporting incubation intervals for every test that's conducted in the unit. Tests also can have a CSV file attached, which can be used for integrating test reports into a water management system such as LIMS. The true advantage with Tecta is our speed to result. And conventional methods, like I said, can take 1 to 5 days. With Tecta, our results can be delivered in 2 to 18 hours. This is an example of our combined total coliform and E. coli test. And based on quantification levels, so for example, 100 CFUs in a 100 ml sample, Tecta would be able to alert you by email with a full test report within 12 hours. As you can see, the higher as concentrations grow, the time to result is quicker. Tecta offers a superior dynamic range to other testing methods. Our range is from 0 to 10 to the power of 8 in terms of our ability to detect quantification. And we can do this in CFUs or MPN. That compares to the membrane filtration, which is only 0 to 80 MPN. Anything greater than that would require dilutions. IDEX Quadritray, they have 2 types, but for the most powerful one, Quadritray 2000, the maximum range is 2419 MPN. Anything greater than that may require dilutions. So Tecta does not require any dilutions or any subjective visual analysis. The machine does the full analysis, and the true advantage is that for highly concentrated samples that have high levels of bacteria, such as wastewater, sewage, sludge, and biosolids, Tecta can deliver results in 2 to 8 hours roughly, and that's compared to 1 to 5 days with other micro methods because they are required to do serial dilutions in very highly concentrated samples. Tecta is not impacted by color or turbidity, and other test methods are. One of the key advantages of Tecta is that we're able to provide a solution to add lab capacity and increase productivity. Traditional labs are restricted to normally Monday to Thursday testing. Often they don't test after hours or on Fridays, Saturdays, or Sundays because they may require to pay someone overtime to come into the lab to do testing. With Tecta, because it's an automated process, once you've launched the test, you literally can leave the test results and be sent to you by email. We're approved by the US EPA for drinking water. Our method type, if you're interested in Googling to see what it is called Tecta ECTC. We're approved by Health Canada. We're also approved for food and beverage by AOC International. We have NATA accreditation in Australia. We are approved by the Philippines Department of Health, New Zealand Ministry of Health, the National Institute of Environmental Research in South Korea. And the US EPA did a very lengthy 3-year study on our method against all other commercially available micro methods for water testing and compared us. And we came out on top across every category. And the EPA summarized stating that our method was the easiest method to use and eliminates the need for a technician. And there was further comments about how sensitive our method is and accurate. Monash University did a study to evaluate us against IDEX, PolyAlert, and the conclusion was that we had a very strong correlation for quantitative performance against PolyAlert, and that we had a faster turnaround time of roughly 12 hours versus 24 hours. So we shaved down the entire test process by half. Here are some of our global customers across 40 countries. We're working with some of the largest companies in the world across various sectors. Some examples: City of Chicago, Rio Tinto, one of the largest mining companies in the world. Intertek, one of the largest commercial laboratories in the world. Sinopec, which is an oil and gas company. Veolia, one of the largest water plant developers. The Olympics had just recently chose our method to test the recreational waters for future water sports in the triathlon events. The applications and industries that Tecta is very valuable and most commonly found in is drinking water, wastewater, sewage, sludge, biosolids, main breaks, recreational waters.
Perdón, Ryan. Últimos 5 minutos. Gracias.
Okay. To give you some case study examples for drinking water, we're used for compliance testing, City of Buffalo, City of Tampa, Las Vegas, Veolia, United Utilities in the UK. We have hundreds of customers that use Tecta for drinking water. For wastewater, we're being used by many customers globally. The results, why they choose us is because we're able to provide results much quicker. In fact, a lot of wastewater operators have come to realize Tecta is a valuable tool in their operation for process testing. What they're doing is measuring the bacteria load before and after certain processes like chemical, chlorine, and UV disinfection, and optimizing their testing processes in real time based on the micro results that they're getting using Tecta. Water main breaks is a very large application for us. Las Vegas is using it. Suffolk County in New York City uses it. What we're able to do is provide a much quicker test result back to the construction crews on site, waiting for a water sample to come back that's clear. Tecta is able to shorten that cycle down quite a bit, and they're able to get the clearance to put the main back online and take down boil water advisories. Sewage and sludge and biosolids are very high value applications because we're able to provide results in 2 to 8 hours compared to 1 to 5 days of conventional methods. Recreational waters, beach water testing, state of Rhode Island has partnered with us and the United States Surfers Association to test ocean water off of the beaches in Rhode Island. Like I said, the Olympics and the ITU World Triathlon Series is using it to make sure the water is safe for water sports. Mining, Rio Tinto, BHP Billiton, Kinross, some of the world's largest miners are using Tectas on site at the mining camps to make sure the drinking water is safe for the employees. Some of the largest commercial labs and public health labs in the world, SGS, Intertek, Maryland Department of Health, and many others are using Tecta for public health purposes and making sure that the water is safe to drink. Universities across the world are using it for research, for project testing. For example, at the University of Miami, Tectas were used to measure the water after Hurricane Irma that was going back out into the ocean. Food and beverage, we're working with Nestle in the manufacturing plant there, where they use Tecta to test the water for washing down the equipment for baby food before they move to a different process within the manufacturing facility. And also the FDA and Myanmar is using it for public health inspection. Sydney Water and PUB in Singapore have installed Tectas on the back of their service vehicles. What they're doing, the driver drives from one sampling point to another sampling point and launches a test. This is speeding up their overall testing process and efficiency. A great example would be if a restaurant calls in because they have water that doesn't look right or it smells off or is discolored, they can send out a service vehicle out, take the water sample, and then launch the test and drive to the next sampling location. The results will be emailed to the driver. He can get back to the restaurant and let them know what's going on with the water. Pharmaceuticals, we're working with pharmaceutical companies for process testing of the water that's used in pharmaceuticals. Oil and gas. This can be used at an offshore oil rig where they have a duct on site to make sure the crews there have safe drinking water rather than flying samples in to a nearby lab, or at a manufacturing facility. Just a couple others, Aboriginal peoples. We have over closer now to 100 units across Canada. These are remote communities where we're providing those communities a way to test the water on premise. Ferries and military, irrigation, and environmental samples are very prevalent for Tecta. We fit very nicely into these industries. We have a myriad of success stories that are on our website. Thank you.
Muchas gracias, Ryan, por esta interesante exposición que seguramente será de interés de muchos operadores que nos están viendo. Lamentablemente no vamos a tener tiempo de evacuar algunas preguntas que nos han formulado.
Okay.
Esta será puesto por escrito porque ya tenemos que darle paso al siguiente expositor, que es la firma Mantech. Aquí estará a cargo de Robert Menegotto, de esta firma, como decía yo, Mantech. Su tema va a ser soluciones analíticas para laboratorios, plantas de tratamiento de efluente y plantas de agua potable. Robert es el presidente y director ejecutivo de la firma Mantech y tiene una licenciatura en bioquímica y una especialización en administración de empresas de la Universidad de Guelph. Reitero nuevamente, las preguntas que no se pueden formular por falta de tiempo serán respondidas por escrito, y aquellos interesados que están interesados en estrechar vínculos nos tienen que mandar un correo electrónico a secretaria@aidisar.org.ar. Ahora sí, entonces le damos la palabra al señor Robert. Por favor, Robert, su turno. Gracias.
Gracias. Buenos días. Thank you very much for the opportunity to talk about Mantech and what we're doing around the globe. I'm a chemist, a biochemist by training, as you have heard. Become an analytical chemist and learned engineering by fire, as I like to say in our company. I will say that little error there. I do not have an MBA from Yale. I'm not sure where that came from. I did receive a minor in a business degree. So Mantech, I will discuss where we are. That's a picture there that we show of a unit at the University of Alberta, which is doing compliance water testing for Canadian clients, both for the university academics as well as for revenue outside. So we're a family company. A little bit of water. And we are a developer and a manufacturer of laboratory and in-factory analyzers for water, wastewater, and soils. And roughly speaking, we have 2,600 analyzers installed in 52 countries now. We estimate that every day, 600,000 samples are analyzed, many of these for compliance. So reporting to the government based on permit issuances. So therefore discharges, drinking water quality. So protecting the environment and protecting public health. And our mission and what our core mission is to make the testing faster than was ever possible, even in a laboratory setting. And starting to evolve these methods into green chemical methods or provide the impact to be green. So for example, a faster test result means an actionable decision in a shorter amount of time. And this will then have significant positive economic and sustainable impacts for the businesses and the communities. And that's our mission. So my background, as I mentioned, I'm a chemist. I come from the laboratory side. And what's happened, so we're 10 years in business as of June 30th. And we started with laboratory analyzers with multi-position auto samplers, or we call them robotics, that, for example, can do compliance, government approved methods for 100 or 200 samples in a batch. So for example, you start your analysis at 4 o'clock in the afternoon, you go home, you come in the morning, and you have 150 samples, 1,000 results done. And so we know how to do that. We do it very well. Then in 2014, we came across a technology for which we own, which is a rapid COD/BOD following an empirical method. So basically similar, if I mention a brand, not similar, different, it's green, what we do, but like the Hawk DQO or a surrogate DBO method. So basically we started getting into the benchtop factories. So the customers of our customers, as I like to say. And what's been happening then is that those clients have been pulling, as I like to say, us to develop these core technologies following often, in most cases, government approved methods into an autonomous online analyzer as well. And what we've discovered now is that we have end-to-end water analyzer solutions. So basically from the laboratory to the factory to the municipal plant, benchtop, online. And in fact, in one case, we have a laboratory unit that is collecting the processed water on the other side of the wall directly in a wastewater plant at the same time as well. So this is our core strength. This is what we do. So for example, alkalinity, total hardness, acidity, SUVA, DQO, DBO, TOC, turbidity, fluoride, a big one in drinking water, chloride, pH, all this, one solution. And we have on a single system put many of these, just again, following those ASTM, ISO, EPA standard methods. It's empirical. The regulatory methods, as mentioned, multi-matrix, so it doesn't matter on a single bench of samples, 100 samples, it could be a mix of municipal wastewater, industrial wastewater, groundwater, seawater, drinking water, any water. It doesn't matter. Our system goes through all of them and knows how to analyze every single sample in there and provide the correct result back. And then multi-treatment point as well. One unit, multi-treatment point, empirical methods. So one solution. So I'm just going to go into this presentation. There's a lot about cases, case studies, different natural user stories, a word I'm using now that I'm getting involved in software development with much younger people than me. So we do automated environmental analysis systems. In most cases, these are accredited, audited laboratories such as SGS, such as Eurofins, such as Environment Canada. And it goes into some others. Sometimes it could be food and beverage, like I mentioned PepsiCo there. They, of course, have the Aquafina water brand sold all over the world. Well, they want to know that that brand and that quality is the same. It doesn't matter if it's in Dallas, Toronto, Jakarta. They want to know that that quality is the same. And that's where these empirical methods come in. So basically, we'll find that we have government as well and commercial, and mainly water. But as we know, agriculture is becoming much more, or farming is becoming, and greenhouses is much more science-based. So the technology and quick testing of empirical methods is leading to an increase in adoption of our technology specifically for that as well. Now going to a case here, an accredited environmental lab, pH, conductivity, alkalinity, and turbidity, as well as absolute color from a single sample. Again, following ISO approved methods, ISO approved methods. And so Eurofins arguably is the largest commercial environmental testing laboratory in the world. There's others, of course, there's SGS, there's ALS, Bureau Veritas, many like that. Eurofins is European based, but all over the world, including in South America and Latin America. So it's multi-country. What we found, there was one of the European sites where they roughly do 40,000 individual samples a year on a Mantech analyzer. And the bottom line, lots of technology of how we do things, how we can do these different parameters from a single sample to the ROI for them was 21 days. And that's key because they're getting the results out faster to their clients, still following approved methods, still following proper quality protocols as per ISO 17025. But they're doing it faster and they're doing it for lower cost. And therefore the ROI to them financially is very, very quick. Another example, this kind of bridges the laboratory to the plant that I'd like to talk about. So 2 cases here. We have El Paso Water in the southern United States and Texas. Then we have the United States or U.S. Embassy. And this being a compound in a high, an area that's not so secure, let's put it that way. And so they have to have internal wastewater treatment. Of course, the El Paso will, as well as the embassy, and monitoring for security. And the key is internal. And then in the case of El Paso, a little bit of the embassy is multi-industry sewer discharges, food and beverages. So for example, in El Paso, they got biofuels, dairy, nuts, Coca-Cola plant, oil recycling, packaging, textile as well. All these factories putting wastewater down the sewer, of course, with their permits. El Paso is checking them to make sure things are fine. So the North American, and I do believe also in South America and many countries around the world, the permit is often based on BOD, which is a 5-day test. So a 5-day test, of course, is completely useless for any decision-making, actionable decision-making. Very good for checking compliance and issuing fines. So we manufacture an automated analyzer to do the 5-day BOD following the ISO EPA method. Been doing that for many years. But it's very useful, for example, for the city of El Paso, learned about this, the city of Calgary now, and like this embassy, just to get a snapshot. What is that BOD that just came in? And what if there's a special project the engineers are running in the plant? Well, they would prefer to have the estimate, and that's what we call it, a 10-minute BOD estimator right away. And that's what we've combined now. We've combined the compliance BOD analyzer with a very quick estimator, all in one solution. So that special projects, quick checking of compliance parameters, as well as getting your approved method reporting that is now can be court defended, legally defended, all in one. It's been a fantastic tool and really gaining a lot of adoption very quickly. So a single analyzer package. As I mentioned, we're being pulled into online analyzers, autonomous online analyzers, and we're excited by it because we're really going to be offering the whole solution for a wastewater plant, for example. Of course, BOD or COD is important, but so is alkalinity, because the carbonate and bicarbonate is affecting from the activated sludge, is acidifying things and affects treatment. So we've often wondered why we have so many alkalinity systems in wastewater plants, and now we actually have a better handle on it and how we can actually integrate this all into one. So for example, the unit is empirical, and I talk about that a lot. No calibrations to the laboratory, but basically a 10-minute COD, multi-matrix. We do a SUVA now, which is specific ultraviolet absorption, which is TOC and UV 254. Dalhousie University has published an application brief about PCOD as the 2-in-1 solution for that now for reactivity. For example, the city of West Palm Beach, pH, connectivity, alkalinity, total hardness in one autonomous online analyzer. Again, following standard methods, EPA methods. And again, a 10-minute BOD with event detection and combined with an event identical benchtop unit with the same method. You can test, cross-check the online, as well as check multiple treatment points if events occur to find out where it occurred. So this is in 2014, we came out with this technology and sold unit number 1. And now it's quite interesting. It's becoming our biggest growth area. This is a COD BOD analyzer. As you see it there, it's a bench top. Really, what it's replacing is roughly the 100 million Hawk dichromate vials that are used for this test per year. And we have eliminated mercury and chromium from the test, as well as the acid and the heat. And it fits our mission. We've developed a green chemistry method that is also much faster. So 10 minutes, roughly speaking, versus 3 hours for the COD, 10 minutes for, versus 5 days for the BOD. So it's meeting our mission of a faster test as well. And again, empirical. So I can take this unit, I can run a COD test at a Coca-Cola plant on the wastewater. Then I can jump in the car and go to a pharmaceutical company with the same unit, no additional calibration or software, go run that pharmaceutical wastewater, then go to a refinery. Same thing, empirical. Very low detection limit, down to less than 1, third-party published both by ASTM and Dalhousie University peer-reviewed paper. The key is it's a nanotechnology. We are using a photocatalyst coupled to an electrode. So basically we are oxidizing the wastewater and the water directly in the unit. So it's an advanced oxidation process. And then we measure the current generated by that AOP method. And that is directly related to the chemical oxygen demand. And one thing that we're very proud of now, we've struck a very tight relationship with the University of Waterloo's Institute for Nanotechnology, from which a recent Nobel Prize winner came out of. And we actually have a manufacturing and R&D laboratory on campus at the University of Waterloo, both for producing these photocatalytic chips as well as improving them. Both the manufacturing side and the efficiency of them. And so we're very excited, very recent collaboration just in the last few months, and very strong, quick forward movement now. So another example I'll talk about case study here is Clean Harbors, or Safety Clean, also called here. Basically, this is a multi-industry, this is a industrial wastewater treatment facility that takes wastewater from other companies. It does 200,000 liters per day. And basically, before Mantech and PCOD, they were 2.5 hours from knowing their COD of the trucks that came in. Therefore, those trucks were gone by the time they got it in. And sometimes they had to call the trucks back to load the wastewater back on because it was above strength that they could handle. So they now know the COD of the incoming trucked wastewater within 10 minutes, making active decisions that are saving lots of money. And then because of the strong BOD analysis capabilities of PCOD, they know the BOD of that treated effluent down the sewer. And so they know well before the city, of course, what they put down the sewer, and it's meeting their permits. And it doesn't matter if it's automotive, if it's a refinery, if it's a brewery, if it's a sugar plant, it doesn't matter. Multi-matrix every day. And the entire plant is operated from PCOD generated results. So generating roughly $500,000 additional profit per year for this company in the one plant. A little bit of a Latin American success story, and very good for the companies, Arauco, CMPC, and Biopapel. But basically, PCOD has replaced the Hawk chromium method, multi-matrix, multi-point treatment again, testing, so it doesn't matter. Multi-units in single mills now because they realize the value of this test, and they increase the amount of testing they do. So if one PCOD unit is busy, even only in 10 minutes, and another sample came in, they get going on it right away. Arauco, who's got many units now, realized more than $3 million in additional profits in the first year of PCOD adoption and operation. So in general, industrial wastewater, it spans multi industries. I'll highlight Cámara, who is a supplier of chemicals for wastewater and drinking water treatment. Cámara is utilizing PCOD to support their customers, putting PCOD in the back of their technical support representatives' cars and going on site. And they can go from one site to the next and provide quick troubleshooting snapshots for their customers and optimizing chemical treatment or even what they should be buying for the customer. So we're involved in anaerobic digestion, AOP control, feedstock control, very important because you can kill a lot of microbes if your COD goes over spec, nutrient optimization, in our oil sands area, pond to pond to river movement. So it's all very quick, reuse and effluent compliance. And again, our mission, fast and green. It's what we're delivering. Our customers are realizing the benefit of that. So one thing that really, Dalhousie University, big shout out to that university in Halifax, Canada. They really found the application of PCOD for drinking water and freshwater sources. So much so that an international method was developed and approved. And it's become this 2-in-1 SUV analyzer now, TOC and UV 254-in-1. It's being dubbed the optimized TOC. And very recently been involved now multi-units in the Ganga River Monitoring Project, internationally funded in India. In the EU, a country has now decided on, along with their TOC instruments, right beside it is the PCOD now to do hydrological river and lake monitoring across the entire country. But this is it's becoming quite a very simple tool as well. I forgot to mention that we did a project where we had elementary students in our local city here taking this unit to the local river downstream from the wastewater treatment plant and doing quick COD, BOD measurements by themselves. So applications, they do span a lot. So of course, we have the municipal with storm events, incoming COD monitoring, discharge compliance, and we're also involved in reuse and drinking water. Industrial, of course, there's plenty of opportunities for optimization, and of course, effluent monitoring. And now in the laboratory, a lot of academics, we're approaching 30 academics using it both as a research theme and as a tool around treatment. And of course, with the green method, we are only using salt and sugar as reagents. We have the safety of employees in mind, as well as I'll mention, we had a brewery who, or food companies are concerned about the hawk chromium method in many cases, and what that vial of chemical is getting into products. And that's been some reasons for adoption of PCOD is to get rid of that vial out of a food factory and get into a green method. So in the end, our mission I mentioned, fast and green, so optimizing the results of our clients, both from a sustainable point of view and profit or cost savings, and therefore protecting our environment and also protecting public health. And so they're green sustainable impacts. So we've got green methods, the fast actionable results. We definitely use not only, even when we do approved government methods, which there is not much flexibility on, we now use less reagents. Therefore, there's less waste, and we even have smaller sample volumes. We only need smaller sample volumes now, and this is leading to improved profit. So it's all delivered, again, by Mantech, complete, full cycle, end-to-end analyzer solutions. And a little bit of fame all over the world. A lot of companies using our technologies, either laboratories, in factories, or academics. Thank you, and willing to take questions.
Muchas gracias, Robert. Sí, veo que hay una pregunta. Jorge, por favor, si puede formularla.
¿Qué tal, Robert? Parece muy interesante la posibilidad que ha mencionado sobre la automatización del sistema. ¿Hay alguna forma, digamos, de indicar que, aparte de DQO y de DBO, ¿qué otros parámetros pueden analizar en forma, digamos, a tiempo real?
Yeah, so basically what we now know is anything we have done in the laboratory for compliance, we can automate, go into an autonomous online real analyzer. So for example, I mentioned the wastewater. Alkalinity is an important wastewater treatment plant parameter. City Toronto runs, I don't know, 150 samples a day. And that can now move to online. Okay, so total hardness, chloride, fluoride for drinking water, fluorination, pH connectivity, very simple, turbidity following the ESO method, things like that.
Gracias. Y
You're welcome.
con respecto al tema de costos, sería bueno que nos indicara el costo del equipamiento y también el costo de el análisis a tiempo real en línea.
Yeah, the range is huge for us because of what we service now. So it's anywhere from $10,000 US to roughly $100,000 US. The online will be right in the middle of that. And of course, depends on how many parameters you need. But that's the entire range. The laboratory analyzers are going to be more in the 50,000 range.
Muy bien. Aquí tenemos una pregunta que consulta acerca de los reactivos empleados. ¿Se utiliza algún reactivo como agua oxigenada, por ejemplo, o algún otro reactivo?
Oxygenated water, no. Like we're analyzing the waters, of course. So everything is natural systems or treated wastewaters or drinking waters. When it comes to conformity of methods, we're using the reagents by approved methods, ISO, ASTM. When it comes to our patented DCO analyzer, we're using a salt solution to help generate current as we measure that. And then we use sugar to calibrate.
Muy bien. Y finalmente aquí hay una pregunta que... Sí, quedó claro. Y finalmente aquí hay una pregunta que creo que ya la presentó, pero de todas formas sería bueno que lo ampliara. Pregunta si está aprobado por entes oficiales. Yo sé que ya explicó que EPA lo ha aprobado, pero tal vez pueda ampliar el tema.
Yeah, so ASTM is the international body that has approved the method for DQO that we use for fresh waters and drinking water systems. And it is a different parameter now than the TOC, because it measures the reactive fraction. All our other methods are already approved by US EPA standard methods and ESO as well.
Gracias, Robert. Y finalmente aquí hay una pregunta acerca de costo de mantenimiento del equipamiento.
Yeah, so that's a multifaceted question because it depends. Is it laboratory? Yeah, is it laboratory, online, things like that? That's a very difficult question to answer because it depends on what the end user has invested in, which configuration. So, for example, the DQO PCOD instrument, you might touch it once a year. You change some tubing, and maybe it's $100.
Muy bien, Robert. Muchas gracias por las respuestas.
Muchas gracias, Robert. Muchas gracias por la exposición. Me permito hacer un recordatorio, ¿sí? antes de pasar a la segunda parte, al segundo bloque de esta presentación, recordándole que aquellos interesados que estén interesados justamente en tomar contacto para un vínculo comercial con alguna de las empresas que en este momento están exponiendo, lo tienen que hacer a través de AIDIS, justamente al correo electrónico secretaría@aidisar todo junto, .org.ar. El otro tema que estaban preguntando en el chat era si estas presentaciones se van a entregar en los correos. En rigor de verdad, se van a hacer a partir de los próximos días. Toda esta presentación va a estar en las redes sociales, tanto de AIDIS, de la página de AIDIS Argentina, como en LinkedIn y algunas otras redes, por un lado, y a su vez en las mismas redes sociales de la Embajada de Canadá. De modo que toda la presentación, cualquiera de ustedes puede tener acceso a ella a través de esas redes sociales. Si ahora me permiten, voy a dar lugar al comienzo de este segundo bloque, ya dedicado al tema de la recuperación de recursos y de inteligencia artificial. Y le vamos a dar lugar, le vamos a dar la palabra a Spencer Snowling de la compañía Hydromantis, quien nos hablará de los gemelos digitales, ¿sí? Modelación para la capacitación, asistencia y operación de plantas de tratamiento de efluentes. Me permito recordar algunas características del ingeniero Spencer Snowling, que es vicepresidente de desarrollo de producto y cuenta con más de 24 años de experiencia en la modelación ambiental, incluyendo 20 años en modelación avanzada de procesos en efluentes y de aplicación en Hydromantis, incluyendo la investigación y desarrollo para el simulador principal de la compañía, que es el GPS-X. Así que ahora le damos paso a Spencer. Por favor, adelante, Mr. Spencer. Gracias.
Thank you very much, and good morning, and thank you for allowing me to present to you. I'm going to be talking about a somewhat different technology now than some of the earlier presentations. What I'm going to be talking about is a software package that allows you to have a digital twin of a real wastewater treatment system, and then use that as a way to train operators and to provide operational decision-making support to your operations staff. So I'd like to start out by introducing our company, Hydromantis. We've been around for over 35 years now. We are most well known for making simulation software for the water and wastewater industry. Our packages that we have are shown across the bottom of this slide here. We're probably most well known for GPS-X. That is a tool that is used by engineering companies for the design and optimization of wastewater treatment systems. However, we've now moved into a new area over the past few years where we've developed a package called SimuWorks. SimuWorks is taking a GPS-X model and changing the interface so that it can be used to teach people about the activated sludge process, and also to make it very easy for people to use the models that are created by our software. The idea behind this is that you can make a digital twin of your plant and allow people to run the simulations of that facility, and you can run it under different conditions. You can make typical performance. You can make very bad things happen in the simulated plant, and then see how the operators will address those issues. We have been approached to do this because throughout the wastewater industry, there is now going to be a significant loss of process and operator knowledge that is anticipated over the coming decade. The wastewater field has a large number of staff members, and it is a complicated process doing biological activated sludge treatment. And so a lot of that institutional knowledge and experience that people have had is going to leave the industry as those people retire. And this graph shows a very typical distribution of ages of operators. Now, this is information for the United States, but I know from working in our industry that is very similar across actually the entire world, that there is a very big bulge of operators who are in their 50s and 60s now, and who are probably going to be retiring in the next few years. So we have been approached to use our simulation technology as a way to train and educate new young operators coming into our industry. Using a simulator as a way to train somebody is in and of itself not actually a new thing. This picture up here in the top right corner shows how a flight simulator was used to train pilots in Canada during the Second World War. It is a small airplane that has a simulated operations panel inside that aircraft. And this person in the foreground is communicating to the pilot who is learning how to fly that aircraft under a number of different situations. And that was a technology that was been expanded and developed over the years. And of course, the modern version of that is a very elaborate airplane cabin that has digital projections of the view of the horizon and so on. And that is a common technology used actually across the world. And it's not just for airline pilots, it's used for submarine operators, and also in the power industry as well. A number of nuclear facilities have simulators that are used to train their staff. And lastly, there is, of course, a common use of simulated patients in the medical industry, particularly for training very much in a hands-on kind of way for ambulance attendees and emergency medical technicians to be able to do something with this simulated patient and get immediate feedback to understand if what they are doing is going to improve the health of that patient. There are actually a lot of benefits of having a good operational staff, as I'm sure you know. There is lots of literature out there in the industry that shows that having better trained operators lowers your plant costs in terms of operations. Having a staff that understand how things are going to happen obviously allows you to run a more robust and more consistent treatment operation. And at the same time, there is also a lot of literature out there that shows that using a simulator is a very effective way to purvey a lot of information into a person as they're learning a new topic. This is particularly true for people, for students and new trainees that are people who learn in a very practical or application and a very kind of hands-on kind of way, the people that learn by doing. And so we have had a lot of success with using our simulators and our digital twin environments for people who like to experiment around and learn by playing with the system in order to gain knowledge and understanding of how all the individual parts of what is a fairly complex system fit together. So what we have then is a package that is called SimuWorks. It is a digital twin of a plant that allows me to run a simulation and get instant results back that says, how is this plant performing under these conditions with this influent loading, and allows me to make changes to the operation of that plant. So what I'm going to do is I'm going to switch my presentation now to my desktop so that you can see the simulator running. Okay, so this is SimuWorks. And if I run a quick simulation here, what this tells me is, first of all, how the plant is performing. I can actually move around my cursor around different parts of the plant. I can click on different unit processes. So the bioreactors here, or the secondary clarifiers, and I can control what is happening in there in the way that you would do it in reality. I can turn on a DO controller and set the set points. I can click on the wastage, and I can set the pump rate for how much we're going to waste from this system. for the sludge. And it's telling me immediately here in this right-hand panel how this system is doing. And in fact, we can see that the quality of this particular plant is actually very good at the moment. And we have a few benchmarks against which we're measuring our performance. So we can see that the BOD is less than 3. We can see that our plant has an effluent phosphorus of less than 2, and our ammonia is 0.1 milligrams per liter. So we know that the plant is performing well. We can also look at a lot of the key process indicators, the operational parameters that people would like to know about while their plant is running. So we can see that our dissolved oxygen that's being controlled by the DO controller is at 2 milligrams per liter. Our mixed liquor is at over 2,000 milligrams per liter. And on this panel over here, we can see we have a sludge age, an SRT of 9.5 days. So those are all things that we know that we want to be able to see what's going to happen at this plant. Okay, so what I can do then is, if I want to learn about how this system works, and if I wanted to understand what happens is if I make a change, I can actually click on, for example, this chemical dosage building, and I could reduce the amount of chemicals that I'm adding. We keep track of things like the energy cost and the chemical cost. So I'm going to actually just reduce this by half. And then I run a new simulation, and that will then show me the results of running this system. So we can see now, once I've reduced that, and then the system has now responded to that, that now we've actually reduced the chemical cost by half. It's now only $30,000 per year. However, immediately we can see that we are no longer meeting our phosphorus limit. That is because I reduced the amount of chemical phosphorus precipitation in this system. So what the users can then do is put it back and see, well, maybe I reduced it too much. I'm saving some money, but I'm not meeting my effluent quality anymore. So let's put it back a little bit, and then it allows people some time to experiment and understand what is the relationship in this plant between the chemical dosage and the operation of the plant and the performance of that plant as well. So I'm going to actually turn it way up here, and we can see that we should be meeting that again, but now I'm actually spending a lot of money on my chemicals. Maybe I could back that off again. So it allows people to understand how these things change. It also allows them to see how the other parts of the system are changing too. Our mixed liquor is now a little higher, and we're now producing a little bit more sludge. So those are things that are part of that training environment that allow people to understand what's happening. Okay, I'm going to go back to, oh no, pardon me. I have one more thing I wanted to show here, which is that we have a number of lessons that are built into this particular package. So this is a hypothetical wastewater treatment plant. It is not a simulation of an actual plant. It's one that we designed to teach activated sludge. And we have some lessons over here that are around that idea. So if I click on nitrogen removal, and then I click on the lessons for nitrification, there's a lesson here that people can go through at their own pace, on their own time, as they understand it, as they move along. So this is just a little bit like a website here where you can go forwards and backwards. It starts by describing what a conventional activated sludge system is that does nitrification. And as it moves along, it describes what the processes should be, how they're supposed to work, and what are the typical ranges for operating a plant that does do nitrification, for example. So what it does is it now leaves the user with a challenge, with an assignment that they have to do. And in that case, we can see here that the plant is currently not meeting those targets. We can see there's lots of things in red here that need to be fixed. So what it's telling us is that we want the users to make adjustments and then run simulations while observing these results. So, and in fact, the lesson will take them through and describe all of the important things that they need to know to solve this problem. So first of all, we're not recycling enough. Our recycle ratio is actually much lower than it should be. So what it's telling me here is if I click on the recycle pump house, this really should be more like 7.2 million liters per day. So if I rerun that simulation, we can now see that, well, I've met that target and some other things are now starting to come in line. But my mixed liquor is still very low. It's only 900. So I can click to the next step, and it talks about that fact. It was saying, really, we are wasting too much sludge. Let's dial this back here. So I'm going to go to 170, and then that will take us the next step as we go through the process. Now everything is good on the nitrification side, but we're still not meeting our target phosphorus. So we can move through these different processes at a rate that everybody is comfortable with. Each individual user can proceed at their own pace. Okay, I'm going to go back to my slides now. Excuse me one moment while I find the correct slide here. Okay. So what this does is this allows a personal plant environment where the person can make adjustments to that plant and learn about what is going on. So we have a lot of confidence that those digital twins, those simulated plants are very robust. They actually give very accurate predictions of what happens at a wastewater treatment plant. The reason we're very confident about that is because they're using our GPSX simulation package that we've had 30 years of development on. That is the engine underneath that is driving all of the calculations. So you don't see that software, but it is the one that is the heart of all of the calculations, and it is the one that tells us what that effluent quality will be. So over the years, we've actually developed this type of a system, not for a hypothetical plant, but for a real plant, for an actual existing plant as well. We do that. Hold on, let me advance the slide. We do that by starting from all of the information we know about a real site in terms of how it looks. We build the underlying model, the process model itself, in GPSX, our design software, and then we put this interface on top to make it so it can be used as a training simulator and also for operations. So I'll show you a few examples of some that we had here. We have a sort of common aesthetic look and style to it that's sort of looking at the plant from above so that people can click on different things. Many of these examples here are in the United States and in Canada. We've done very complex plants with this one in Texas, very, very simple plants. This is one that's actually only about 45 minutes drive from where I am right now. A very, very simple plant. It has complex operation in the sense that it is a very new plant that is underloaded. However, they have a training simulator that they have developed for that plant to educate their operators about how to run that one. We have done it for different facilities all over North America and around the world. This is an interesting one that we developed that teaches how a new solids handling facility was going to be handled when it came online. We actually built a simulator of the design of the system before that system was built. So that way the operators got a chance to play with that system and understand what was going to happen before the thing came online. So that way it was easy for them to anticipate what they needed to know. We've also done them in many other different languages. Here's one that we did in China. We've also done them in Denmark and other places around the world. We don't have one in Argentina yet, but we do have users of our software there as well. And one of the things that's been really fun and interesting is to use this simulator as part of the operations challenge competition. And I'm going to come back and talk about that a little bit later. So what I would like to do then is talk about, sort of take the concept of how we use this as a training tool and actually extend it for now facilities that have a simulator of their own facility for a real world digital twin. These people use this now not only for training, but actually for doing testing and understanding of how their system works when they need to make changes to the operation. So this is a facility that's just outside of Salt Lake City in Utah in the United States. And we have had this facility using our software for many years now. Myron Bachman, who is the superintendent at that plant, has told us many times that he uses the software to help make decisions and to help educate his operators about where they're going. they use the model on a regular basis, say every month or two, as new changes are coming online to their plant, as they need to make decisions, and they can test those decisions in the simulator first before they implement them in reality in their plant. We also are able to do a lot of documentation as part of our system as well. So the one that I was mentioning earlier, the very small plant that is located nearby here, we have built them a system where when people complete the training exercises, like the one I showed you earlier, that they can produce a document that illustrates how long, who the person was, how long they spent to do it, and what information was covered in that particular exercise that they completed. So it has sort of two uses in that sense, that it can be used for training and it can be used for operational decision-making advice. Over the years, we've had to make sure that we made the software easy enough to use so that anybody could sit down and get started and use it, and that they understand what the model is trying to tell them. This digital twin, they may understand when they look at the picture which buildings to click on, but they want to make sure that we have acceptance from those plants, that they agree that this thing is a useful tool. And we've had many attempts at this over the years, but SimuWorks has really been that breakthrough for us, where we were able to make an intuitive design that allows people to do it in a very hands-on kind of way. And I mentioned the WEF, the Water Environment Federation Operations Challenge competition earlier. So we have been now using that simulator as part of that competition for many years, where we put a simulator in front of the teams. They actually do it as part of the very first event, the process control event. And we give them plants that are not meeting their required effluent quality, and they have to troubleshoot and figure out and fix the problems at each of these simulated wastewater treatment plants. So the digital twin is doing the job of giving these people a challenge that they have to sort out and fix. And so we've had really good success with this over the years. And I know that Aeration has actually helped support a team from Argentina that has come to compete in the competition. I have met them actually a couple of times. And I know they've actually scored very high scores on the simulator as well. And they've done really well in the process control event as part of that. So WEF also uses that the simulator as part of their WEF Max operator training sessions in many different places throughout the US. And we won the 2018 Innovative Technology Award for our product and for our participation in the Operations Challenge competition. So we have a number of different users throughout the world and throughout North America in particular, agencies, universities, training companies that are doing that sort of educational aspect. But again, many different facilities and municipalities are also having digital twins made of their systems. So here's some examples on this slide of various places where we have done this, such as the city of Cincinnati and in Cleveland and so on, places where they want not only our training package, but an actual simulator of their system, an actual digital twin of their particular system. So the training can reflect what's happening at their plant. So I think I'll sort of conclude here with a few slides that talk about how these things go forward, how we build these things for you. So if we were to proceed in building a digital twin of your plant, we have to start by receiving all of your specifications about your plant. So we need to see the drawings and the measurements and the regular data that you will have collected over time. We then build the model in-house here in our office and then match those model predictions to the field measurements and the data that you gave us. We calibrate the model so that it produces the correct results. And then we work with you to define what are those lessons? What are those things that you would like your operators to learn about while they are using the digital twin? So we build lessons around those. We usually build sort of 5 or 6 different lessons based on different topics that are important to you. And then we hold an online training session for half a day just to get everybody familiar with how to use it. And the costs, they vary. It really depends on the complexity of your plant. So it's a lot more work, obviously, to set up a digital twin of a very complex plant. So the way we usually do it is we would like to learn the details about your plant, and then we can provide you with a proposal that covers that. There is a fee associated with setting it up in the beginning, and there's a cost for that. And then there's an ongoing annual license subscription to keep the software going. And we come back and chat with you every year to determine, is there any changes you've made to your plant that we need to reflect in the digital twin as well? And is there any new lessons that you would like, and so on. And these licenses can then be on standalone computers, or they can be networked together. Usually this is a project that takes us, with some back and forth of information exchange between yourself and us, and we have a beta testing period and so on. Usually those are things we can do in 3 to 4 months, and we would just like to learn more about your plant if you are interested, and we can keep in touch. So to conclude, it is a completely unique product in the wastewater industry. SimuWorks is the only thing that is being used in this way by WEF and by others. And we have really received solid acceptance from operators, on the front line there through its use in the Operations Challenge Committee and through the training programs as well. And I'll end by saying the biggest feedback that I've always gotten from people who use these simulators is that they are fun. They are fun to use. It is a really nice way to have very strong engagement with your staff. It's fun to run the plant and to break it and then fix it again and understand. And it's a really nice way to get people excited about learning about how these systems work. Okay, so I'd be happy to answer any questions.
Muchas gracias, Spencer. Vamos a dar lugar a algunas preguntas. Tenemos muy poco tiempo, pero seguramente Jorge Durán podrá resumir y extractar alguna pregunta para poder responder en estos par de minutos que ya tenemos. Adelante, Jorge.
Bueno, muchas gracias, Spencer, por la presentación. Acá hay varias preguntas, pero la primera sería si SimuWorks se limita a sistemas de cultivo suspendido como los barros activados, o ahí también es aplicable a otros sistemas de película fija o procesos anaeróbicos.
Yes, we can actually simulate any type of wastewater system. So we can do conventional activated sludge. We can do biofilm systems like trickling filters or IFAS. And we can also do the whole solids line as well. So dewatering, anaerobic digestion, and even side stream treatment processes like struvite recovery and Animox, those types of systems as well.
Muy bien. Otra pregunta aquí está relacionada con el costo, que de alguna manera lo has comentado, pero si existe primero una relación del costo con el tamaño de planta, que creo esto lo has mencionado, y piden un ejemplo de costo, por ejemplo, para una planta compacta para 3.000 habitantes. ¿En qué orden de costo estaría el modelo?
Generally, our projects range from $30,000 US dollars up to 60 or 70,000. That is a package to build everything from scratch and get it installed in your system. And then there's an ongoing license fee that is usually around $3,000 per year after that.
Bueno, y acá hay una consulta de si estos simuladores tienen versión en castellano.
We have actually been working on translating our training package into other languages. So we have the ability to translate them into other languages, and we've done it for Korean and Japanese and Chinese and so on. We have not yet done Spanish, but we would be happy to work with somebody who could help us do that. That's
Bueno, y ya ha explicado que hay un entrenamiento del paquete, que fue otra de las preguntas, así que básicamente esto es, digamos, el grupo de preguntas que teníamos, ya que tenemos poco tiempo.
Okay.
Muy bien,
Okay, thank you
Jorge,
very much.
gracias. Gracias, Jorge. Gracias, Spencer, por la explicación.
Thank you.
Y entonces ahora vamos a dar la palabra a la compañía ETA, Engineering and Technology Associates. Aquí van a hacer uso de la palabra Marius Caprariu y a su vez Jean-Sébastien Charron. En el primer caso, Jean-Sébastien es el presidente de Conexport, empresa de consultoría para ofrecer un servicio a empresas canadienses innovadoras como ETA, justamente, en la búsqueda de sus objetivos de desarrollo comercial internacional en América Latina y el Caribe. Jean-Sébastien previamente fue gerente regional de la Agencia de Crédito a la Exportación de Canadá, Canada Export Development Canada, en América Latina y en el Caribe. Por su parte, el ingeniero Marius Caprariu es director de ingeniería de la empresa, cuenta con más de 28 años de experiencia en distribución de agua, sistemas de drenajes cloacales y plantas de tratamiento de efluentes y plantas de tratamiento de potabilización del agua. Ha participado en numerosos proyectos de índole industrial y municipal y cuenta con una amplia experiencia en lodos activados, reactores SBR, MBR, MBBR, manejo y gestión de lodos, desinfección por radios ultravioletas y reuso de aguas. Así que damos la palabra a estos dos profesionales. Justamente, por favor, Marius, por favor, Jean, el tiempo es de ustedes. Gracias.
Muchas gracias, Juan Martín. Es un placer estar aquí con todos los participantes hoy. Gracias a IDIS, la Embajada de Canadá, la Cámara de Comercio, Gobierno de Ontario, por la organización de este importante webinario. El objetivo de Engineering and Technology Associates, Inc. es de traer tecnologías innovadoras y inteligentes que ofrecen un salto cuántico para el tratamiento de aguas residuales, tanto para municipios que varios sectores industriales como alimentos y bebidas, el sector minero, el sector agrícola, granjas lecheras, entre otras. Una tecnología que ofrecemos optimiza el equipo existente, ahorrando importantes gastos de capital y tiempo de construcción. Otras tecnologías que tenemos traen beneficios claves como reducciones importantes de costos de operaciones y costos de energía. Hemos tenido mucho éxito en América Latina y el Caribe a través de varios proyectos, incluyendo un proyecto muy importante que les hablará Marius con Aguas Andinas en Chile. Dejo la palabra ahora a mi colega Marius para hablar más en detalle de estas tecnologías importantes y estamos muy atentos a sus dudas o preguntas. Muchas gracias y buen día.
Thank you very much, Jess. And I want to thank everyone for having time to listen to our presentation. I think you learned in the previous presentations about monitoring, about simulation. Now, I think it's now our turn to explain a little bit about technologies and how these technologies can make a big impact towards the sustainability of each facility. I have a couple of technologies to go through. The first one here is the activated granular sludge. So these are like a different sludge, different than the flock-based activated sludge. And this was implemented successfully in Chile, and I will go through the project and you'll see the benefits. First, the technology was developed in Switzerland, and here at the plant in Glarnerland, which is about 50 kilometers south of Zurich, we had the possibility to test full scale the technology and provide comparison between granular activated sludge and conventional activated sludge. So here, as you see at the plant, we have 4 aeration tanks large aeration tanks. We convert 2 of them to granular activated sludge, and then we compare side by side the performance of the activated granular sludge versus the conventional. Here at the plant, we installed our key features for our technology. First, we do have a decanter hydrocyclone. This separates due to the high centrifugal forces that we develop. It's about 150 Gs. We separate the heavier particles that are settled through the bottom by the lighter fraction that are wasted through the top. So here I will show you, these are like the mimics, which are the synthetic granules that we add into the wastewater. And that's added only once when we try to produce the granulation. So these are like the mimics, and they are from Chile. They are exported here into Canada. And these are like introduced into our tank to enhance and then the operation and then start producing the granulation. How we change the system? Well, it's a very, very simple addition. As a normal wastewater treatment plant conventional, we do have the aeration tank here, and then we have the secondary clarifier. We are taking the return activated sludge, and then that's being returned at the head of the aeration tank. But all the waste activated sludge that normally goes to the thickener, it will go through our hydrocyclone. So in a big plant, in a conventional activated sludge plant, the only change is that we have our hydrocyclones on the waste activated sludge line. So what exactly happens? Well, as we have the hydrocyclones and we introduce the mimics, the inert material into the wastewater. Here you see them, they are virgin. There are no attachments to it. And then because we apply load into the aeration tank, we will create the heterotroph bacteria. So then we produce the AOBs, NOBs, filamentous bacteria, nitrosomonas, nitrobacter. Well, these bacteria, as we know from other attached growth systems, they will attach to our mimics. So they will attach to the mimic and they will not swim on their own. So we are producing the granules that then will go into the hydrocyclone, and because of the gravitational force will separate. The granules are returned back into the aeration tank, and the AOBs and NOBs, they are wasted to the thickener. What happened in Glaneland, and this is the plan that I showed you in the picture where we compare side by side the two systems, conventional activated sludge versus the granular activated sludge. As you see here, the SVI in the activated sludge plant was generally about 800 milliliters per gram. That's during the winter times. And as you say, well, not a good run plant. After we had we add the mimics for about a month, and you can see that the SVI dropped and then stabilizes to less than 100 milliliters per gram. At the same time, the settling velocity in the secondary clarifier was about 0.2 or 0.3 meters per hour. After we produced granulation, that settling velocity increased to more than 4.5 meters per hour. So that gave us the possibility to treat a lot more flow and have a lot better effluent quality. The plant that we did in Chile, this is a plant Buimaipo. It was Buimaipo is about 30 kilometers south of Santiago, and the client is Aguas Andinas. The plant, it's not a conventional, like a typical flow-through plant. It's 4 SBRs, and you can see here there's like 4 large SBRs. Each tank is about 50 meters long by 23 meters wide and 6 meters deep. The plant was designed to treat wastewater coming from approximately 60,000 people, and they were exploring a 50% expansion. So that's like a treat, not 60,000, treat 90,000 people. We participate in a tender, and we've had two options. One option was to provide 2 additional SBRs, as you see here. They're a little bit longer because the site did not allow to have the same geometry of the tank. And of course, provide a secondary, a second thickener, another digester, and upgrades to the preliminary treatment. With our technology, the second option, S-Select, we expanded the plant and keep only 4 SBRs. So instead of constructing 2 additional large tanks, we provided the expansion with only 4 SBRs. So the construction time decreased from approximately 2 years to about 6 months. So that's like a major reduction in construction time. But at the same time, the capital cost for the biological treatment was reduced in half. So those are the key parameters that were at the beginning explored by Aguas Andinas. Of course, there is a lot of other benefits in terms of the effluent quality. So this is when we started the project. We signed the contract on, I think it was end of June 2018. By middle of September, all the equipment was already shipped and installed in Chile. So you can see it was like only like 3 months turnaround for the equipment to be there. We had start injecting the mimics on October 17, and you can see them here in the wastewater. They're like virgin, like there is no attachment. The same a week later, we can see there is all starting to be some growth around the mimics. And then on January 21st, we finished, and then we're ready to start the performance test. And you can see here, this is the mimics, the original one, and this is what we create, a live granule. So based on an inert, like a dead body, we create a live. So Frankenstein is for sure true, because this is the proof that it actually exists. So we started the trial, the performance test in beginning of March, and then we guaranteed a settling velocity of 3 meters per hour. And as you see here, we started from about 0.5 meters per hour, and during our performance test, we achieved like 8-9 meters per hour. The same. It's not only one SBR, all 4 were at the same performance. So this is a picture showing what, when we start the mixing into the SBR, what is the mixed liquor. And then you can see the difference here between a normal mixed liquor and our conventional activity, granular activity sludge. So in terms of benefits, we produce a turbidity of less than 1 NTU. The total nitrogen in the effluent is less than 3 milligrams per liter. The phosphorus is less than 3. And we increase the dryness of the cake by 5%, also cutting the polymer consumption. And as you see here, there is the second thickener that was built is on a standby because it's not needed. So the key features for the technology, it can be easily implemented in any activated sludge plant existing. It provides excellent settling properties. We have a very small footprint, so we can possibly expand the existing facilities by 2 or 3 times, depending on the case. Excellent effluent quality. We have ammonia that less than 1 milligram per liter, suspended solids of 1 to 3 milligrams per liter. There are no chemicals involved. It can be SBR or continuous. Very attractive for new greenfield plants, and it can be easily implemented to all the activated sludge plant. The second technology is treatment of highly concentrated ammonia streams. That involves our coworkers, like the red bacteria, the Anamox. And this is like show a comparison on how big these are, like in comparison with a paper clip. They are about 0.2 millimeter. That's the size of the granule. And as you see them, they are all red. So what does this technology does? Well, where we have the conventional activated sludge that we go through aeration tanks, secondary clarifier, thickener, digester, and then we have the dewatering, where we dewater the biosolids. The cake is taken for offsite disposal, and then we have a very small stream here, like it's about like 0.2% of the entire flow, but that stream contains 25% of the total ammonia. So there comes like how to treat that. Is it better to treat in the large aeration tank or implement a smaller system that will treat the small flow a lot more efficient? So we have the Anamox bacteria that, as we explained, like the nitrogen cycle here, we have the ammonia, and then through the AOBs, we convert them to nitrite, and then through the NOBs, we convert to the nitrite. And then we have, from nitrate, we have additional carbon source because this stream comes from a digester. So supposedly we should not have any carbon left. We add methanol and we go and produce the denitrification. So what the Anamox does, it produces a short circuit from the ammonia. We oxidize through the ALBs or nitrous ammonias, and we produce the nitrite. And then from here, based on Anamox, we produce a short circuit and release as nitrogen gas. Different representation, but the same concept, that we go from ammonia, we apply only 50% of the energy, and then we produce the shortcut to nitrogen gas based on the Anamox bacteria. Well, this plant was shown to you before, but it's the same plant in Glarnaland, where we do have an SD facility. It's been in operation for more than 15 years, so it's not a new process. It treats about 220 kilograms of ammonia per day. Here at the plant, as I showed you before, but from a different angle, we have 4 aeration tanks. And this is like the small tank that treats 25% of the entire ammonia. So when you think like it's like very, very small compared with the large tanks that are here for removal of the nitrogen and BOD and COD. Again, the technology involves a hydrocyclone, and that's like kind of key to all our technologies because we produce a very good separation of the sludge. And then a representation with the AOBs, NOBs, and Anamox. Well, Anamox and NOBs, they all compete for the nitrite. So we have to find conditions that we can suppress the NOB, and we can also enhance the capability and make the Anamox to thrive. The Anamox is 10 times slower in terms of growth than NOBs. So how we do that? Well, we have the same thing with the nitrogen triangle, and then through the hydrocyclone, we waste the NOBs, and then we can produce a sludge that it's mostly red bacteria. So when we have a red bacteria, the Anamox process works very well, and then we produce a very good effluent quality. This is not a modern paint of the year. This is actually a picture of our mixed liquor. And what's important is that we have 2 SRTs here. As you see, the granules, the Anamox, they have an SRT of 50, 60, 70 days. And then the AOBs and, the AOBs, NOBs, they have an SRT of about 7 to 8 days, sufficient to produce the nitrification. So that's important because we have 2 SRTs in our tank. We've done the plants in SBR mode or in a convention flow-through system. In the flow-through system, there is no decanter. The equipment is smaller, but only the waste, the pump that provides the mixed liquor to the hydrocyclones, it's a little bit bigger. So in a nutshell, the deammonification process based on Anamox, it provides about 60% energy savings. There is no addition of carbon. We have a CO2 fixation. We are minimizing the sludge production, and the operators that are operating these facilities are laughing a little bit less because this type of system is producing a reduced amount of laughing gas, which is N2O. So that's like something good, because it's like funny to go around the wastewater treatment plant and see operators that are laughing all the time. Simple and flexible technology. It's a major step towards an energy self-sufficient wastewater treatment plant. And we're looking at coupling this technology with other very energy efficient mainstream treatments where the plants can actually produce power. So they are not a net importer of power, they will be a net exporter of power. It was nominated for the World Energy Global Award in 2007, and now there are more than, well, it was 15 years of experience worldwide, and it's a patented technology. The third technology, because we're in Argentina and all like a nice steak, well, I think we should do something about the cattle industry as well. So it's a very efficient on-site treatment for the cattle farms. The dairy farms, they produce a lot of manure, and then of course there are regulations that can result in fines. There is an environmental hazard, and then also there is a negative public perception about it. When you look at the dairy farms as a global problem, well, you can see the amount of waste produced per day. It's a lot more that is being produced by cows than humans and pigs. Well, actually, like, between humans and cows, there's about 7 times more waste it's produced by the cows. So the regulation, the technology came from Israel. Of course, like in Israel, there is no pigs, so they did that on cattle. So it was implemented in 2019 because of the new regulations. And the technology Claritech is a unique, innovative technology that consists of a compact coagulation, flocculation, filtration. So that provides a ability for a plug-and-play system that can be easily implemented for a lot of cattle farms. So when we look at improving the sedimentation tank, we are looking at improving either like the dissolved air flotation and also the filtration system. So as I said, this technology, it's very compact in size and footprint. It's low cost in operating expenses. It's scalable because as you expand the facility, you can add more of these treatment systems to allow for more cows that are at the farm. It can be fully automated and remotely controlled. The residual sludge is already dewatered, and the construction permit is not required. These are like some of the systems that can be they have a lot of instruments and control valves that they allow us to monitor the treatment system even from Canada, from Israel, from other places. And then when we see a problem, then we can call the operators and they can make some changes to it. In terms of the product family, there is like systems that are for 350 cows, 650, 1,000 cows, but also can be expanded to a lot more, depending, like adding like 2 or 3 systems together, so they can allow for a lot of cows. These are like a list of reference list, all based in Israel because of the new regulation. And with that, some pictures of the existing, some of the facilities that were installed. And you can see it's all clean around here. There is not a lot of manure on the site. With that, I thank you very much. And then I will be open for questions and answers. Thank you.
Bueno, muchas gracias por la exposición. Vamos a dar lugar a alguna pregunta que Jorge Durán tiene para formularles y luego seguimos. Adelante, Jorge.
Gracias. Acá una de las preguntas sería si se requiere mayor energía de agitación para agitar la biomasa granular aeróbica.
Yes, it's a little bit more. Like, for example, in an SBR, because we operate in an on and off system, we provide an additional mixer just to make sure that when we start the mixing, we are suspending all the biomass, which is important. We don't want the granules to be at the bottom of the floor. Now, in a conventional system where it's a flow-through system, because the gravity, specific gravity of the granules is slightly higher than the water, we do not put any additional mixing. But for cases SBR, we do require an additional mixing.
Y la otra consulta sería, dado que aumenta mucho la densidad, la concentración de biomasa, ¿es necesario aumentar la capacidad de aireación también para aumentar la transferencia de oxígeno?
Well, very good question. Like, we have the possibility to operate at a very large concentration, like a biomass, like 8 to 10 grams per liter. However, what we've seen in the from our plants in operation, at the same biomass level, like say a mixed liquor of 3,000 milligrams per liter, we are at least 60% more efficient. So we encourage our plants to be operated at a lower mixed liquor concentration. At higher concentration, it's different than an MBR, where you do have the alpha factor going down because of the higher mixed liquor. We see even at the higher concentration that we keep the same alpha factor. And that's kind of surprising. At the same mixed liquor concentration, we do see a slight improvement, but we count at the same alpha factor.
Bueno, muy bien, ya contestó la pregunta siguiente, así que se lo agradezco. Y por otro lado, quería consultarle sobre el costo de la implementación de estos mimics para la granulación.
As I explained in the plant in Buin-Maipo, there was a 50% reduction in the construction cost for the biological reactor. You can imagine, like, if you have allocated, like, say, $10 million for an expansion, well, you actually, by implementing this technology, you will only put 5 million on the blocks. The 5 millions can be used for something else. And we've seen at the plant in Glarnaland where they deferred the expansion because they were able to treat within like 50% of the infrastructure, they treat 100% of the flow. So that was like expansion of the plant by 2 times. What we see in the plants is the bottleneck is the pipe between aeration tank and the clarifier. If we do some innovative designs around that, we can actually increase the size of the existing bioreactor and the clarifier by at least like 2 or 3 times.
Por último, quería consultarte con respecto a este equipo Claritech que presentaron últimamente. ¿Cuáles son los rangos de caudales dentro de los cuales se maneja normalmente y el nivel de humedad que se obtiene de los lodos producidos?
Right. I think in terms of the cake, it's probably upwards of 50%, like the concentration weight by weight. In terms of flow, it can be like, say, from 50 or like 10 cubic meters per day up to, say, almost like 1,000 cubic meters per day, depending like on the type of systems. And based on modularity, we can build up the systems to suit the farms.
Claro. Bueno, muchísimas gracias, Marius. Ha sido muy claro.
Bueno,
much.
Muchas gracias, Jan. Muchas gracias, Marius, por este aporte innovador para la optimización de sistemas biológico de tratamiento. Bueno, y ahora en esta última presentación del webinario le vamos a dar las palabras a Juan José, quien nos hablará sobre la valorización de los residuos orgánicos, tanto en líquidos como en sólidos, y su tema para esta presentación será recuperando valor de residuos orgánicos, líquidos y sólidos, y también aquí la presentación será en idioma español. El ingeniero Juan José es el jefe de ingeniería y tiene más de 20 años de experiencia en ingeniería, en digestión anaeróbica de lodos en efluentes municipales y materias primas industriales y agrícolas, incluida la codigestión de lodos en aguas residuales y residuos de alimentos. A su vez, también Juan José tiene experiencia en el manejo de biosólidos, recuperación de nutrientes, procesamiento de biogás, tratamiento de aguas residuales y municipales e industriales y procesamiento de residuos sólidos para la extracción de orgánicos. A su vez, Juan José tiene varias patentes estadounidenses e internacionales relacionadas con procesos y equipos de recuperación de orgánicos. Así que, con estos antecedentes, le damos la palabra a este último expositor. Juan José, todo suyo. Gracias.
Muchísimas gracias. Les agradezco muchísimo por esta oportunidad a la Embajada de Canadá en Argentina, a IDIS, a los organizadores y a todos los participantes en este webinario. Quisiera confirmar que ustedes pueden ver mi pantalla.
Sí.
Perfecto. Entonces...
sería conveniente que la amplíe. Pruebe de ampliarla con el iconito de abajo del PowerPoint, la copa.
Veamos. No.
Es que no está en presentation mode. Estamos viendo los slides a mano izquierda.
Ah, entiendo. Déjeme ponerla en presentation mode. Quizá tengo que cambiar el share. Espérenme un segundo. Lo hago nuevamente. Ok. Ok. Vamos a hacerlo entonces. Denme un segundo. Share screen. Entiendo. Por algún motivo, creo que lo que voy a hacer es simplemente entonces ampliarla aquí. Esto ayuda. Veamos si la pueden ver en... A ver. Por algún motivo, no se convierte. Lo que creo que voy a hacer es mover. Bueno, entonces empiezo. Vamos a ver. Ahora es mejor. ¿Ven?
Sí, ahora se ve todo.
Perfecto. Gracias. Entonces, la presentación está relacionada con la recuperación de residuos orgánicos de toda forma de desechos urbanos. Quisiera confirmar la primera parte, ustedes están viendo Our Vision, a Zero Organic Waste Future. ¿Es ese el slide que ustedes están viendo?
Sí, ese es el que vemos.
Perfecto. El concepto de energía es un concepto de un futuro sin desechos orgánicos. Para nosotros los desechos orgánicos son recursos y no son desechos. Entonces, como ustedes ven, de todo tipo de desechos que generamos en las sociedades urbanas y también en las sociedades rurales, estiércol, desechos de procesamiento de alimentos, etcétera. Nosotros aplicamos diferentes tipos de tecnologías para recuperar energía en forma de electricidad o de gas, material reciclable a partir de los desechos urbanos, sólidos, y siempre hay como residuo luego de la digestión orgánica, hay la producción de fertilizantes y de agua que puede ser reutilizada. Las tecnologías que utilizamos están siempre basadas en digestión anaerobia, que es el centro de nuestra operación. Energía quiere decir energía anaerobia. Y siempre en adición a la digestión anaerobia hay procesos previos a la digestión y posteriores a la digestión que son necesarios para completar la recuperación de recursos. Energia es una compañía canadiense con sus headquarters en Burlington, Ontario, pero tenemos una presencia global y nuestro trabajo está principalmente relacionado con ofrecer soluciones, sistemas que solucionan problemas de nuestros clientes, no solamente la venta de equipos, nosotros manufacturamos también equipos especializados para nuestras aplicaciones y tenemos habilidad de hacer desarrollo de proyectos, financiamiento en ciertas partes del mundo, no en todo el globo, ingeniería de procesos, ejecución, y en muchos casos también podemos hacer venta de equipos, pero típicamente nuestra preferencia es ofrecer soluciones completas. Este slide muestra dónde tenemos nosotros oficinas, muchísima actividad en Europa, en Canadá, en Norteamérica, y también en el sudeste asiático. Tenemos operaciones en Singapur y también en Cape Town, en Sudáfrica. En números, nosotros tenemos una gran cantidad de digestores, generamos muchísima electricidad renovable y también mucho biogás. Somos una compañía tecnológica, entonces tenemos también patentes. Y manufacturamos los equipos que son críticos y diferenciados para nuestras plantas. Muchos otros equipos utilizamos de compañías con las cuales tenemos convenios para ofrecer equipos complementarios a nuestras plantas. Esta es quizá la parte...
Sorry, Juan Schultz, the presentation is not being watched in the presentation.
It's not, okay, the presentation, you're saying the presentation is not moving. Okay. Is it now? Can you?
Yes, it is now. Yes, it is now. It is now moving.
Okay, you are seeing Energia solutions to recover value from waste?
No, organics to value expertise and technologies.
Okay. Understand. Perfect. Now, Vamos a esta parte. Entonces, en cuanto a las soluciones que ofrecemos, estamos hablando de primeramente los procesos que ocurren cuando se generan desechos y nosotros extraemos materiales orgánicos de los desechos y luego estos materiales orgánicos van a una planta de digestión. Típicamente cuando se extraen orgánicos de basura, etcétera, es importante hacer un pulimento de estos materiales. Luego de la digestión anaerobia hay separación de sólidos y luego hay el tratamiento de los líquidos para recuperación de amonia y para producir un efluente de buena calidad, como nosotros utilizamos bioreactores de membrana. Y también para los sólidos residuales hacemos secado y para el secado utilizamos en muchos casos energía que proviene de pirólisis de los lodos secos. Esto lo hacemos típicamente en plantas de aguas negras. Vamos a enfocarnos a plantas que tenemos en algunos continentes. Ustedes pueden ver aquí plantas en Ciudad del Cabo, en Sudáfrica, otra planta en Europa, en Limassol. Tenemos plantas en Inglaterra, en Italia, plantas en Toronto. Esto es simplemente para mostrar el tipo de plantas y equipos. En este caso estamos mostrando sistemas para desechos sólidos, sistemas para desechos de comida, como es el caso de Cardiff y de Toronto. Las otras plantas son plantas completas de desechos sólidos donde estamos extrayendo orgánicos y material reciclable y luego hacemos digestión anaerobia. En el próximo slide estamos mostrando plantas en Norteamérica. Utilizamos una tecnología para extraer orgánicos que se llama OREX, que son prensas extrusoras, en donde no importa realmente la calidad o el nivel de contaminación de los desechos urbanos. Típicamente hacemos una preseparación de la basura con tamices vastos y luego ese material va a estas prensas y en estas prensas, aplicando presión, separamos el material orgánico de los desechos. Y ese material orgánico espeso, es un cake, alrededor de 30% de sólidos, lo pulimos y lo ponemos en digestores, y tenemos digestores de varias capacidades, y en muchos casos, en el caso de estas dos plantas, Victor Valley e East Valley en California, esas son plantas de codigestión. Cuando nosotros extraemos los orgánicos de la basura o de los desechos de comida urbanos, luego hacemos un pulimento y los digerimos junto con lodos en plantas de tratamiento de aguas servidas, de aguas negras, y hacemos lo que nosotros llamamos codigestión de este material que traemos, que está pulido y es un material muy digerible y con alto contenido de carbón, y generamos biogás junto con el lodo de las plantas. En general, aquí estamos mostrando gran cantidad de digestores que tenemos en diferentes partes del mundo, digestores agrícolas, de estiércol y de desechos agrícolas, otros digestores más a nivel industrial, donde estamos digiriendo desechos de plantas que procesan cárnicos, etcétera, slaughterhouse waste, solamente para mostrar algunos ejemplos. En general, como ven, tenemos una experiencia larga en en la instalación de sistemas de digestión anaerobia. Me voy a enfocar ahora en la extracción de orgánicos de la basura y cómo nosotros pulimos los orgánicos para producir un material que es de buena calidad para ser digerible. Esta es una parte importante porque muchas veces vemos que en las ciudades, pese a que la misma municipalidad está encargada del manejo de los desechos sólidos y del manejo de las aguas negras, típicamente son dos agencias que nunca se hablan la una a la otra, ni unen esfuerzos para tratar de solucionar problemas en conjunto, pero nos damos cuenta que hay un gran nivel de sinergia entre estos dos tipos de agencias, porque típicamente la capacidad de digestión existe en muchas de las plantas de tratamiento de aguas servidas, de aguas negras, y estas plantas tienen una gran demanda de energía para el tratamiento de los líquidos por aireación. Entonces, es ideal crear capacidad en esos digestores y traer material orgánico de las estaciones de transferencia de basura, extraer el material orgánico y en lugar de mandarlo a los rellenos sanitarios, donde se genera una gran cantidad de metano que va a la atmósfera y contribuye a los gases de invernadero, es preferible extraer esos orgánicos, solo mandar los desechos no orgánicos a los botaderos, a los landfills, y traer el material orgánico a las plantas de tratamiento, que es lo que nosotros hacemos en este caso, para generar energía que puede ser utilizada por la planta de tratamiento. Y luego de esto, pues se genera energía y agua. Esto muestra la manera más típica de hacerlo cuando podemos tratar cualquier tipo de cualquier tipo de desechos urbanos, hacer extracción, luego de eso hacer pulimento, y siempre hay las alternativas o bien de llevar el material orgánico a una planta digestora dedicada, o alternativamente pulirlo y llevarlo a una planta de tratamiento de aguas residuales, donde se puede hacer codigestión de los lodos de esa planta junto con este material orgánico que se trajo desde fuera y generar todo este tipo de recursos como gas renovable, electricidad y fertilizante. El próximo nos muestra el tipo de desechos en los cuales hay material orgánico. Nosotros entendemos que realmente en muchas comunidades se trata de hacer separación de orgánicos en la fuente, a nivel residencial, etcétera. Y nos damos cuenta que pese a que haya ese esfuerzo de separar orgánicos, nunca los orgánicos vienen con, al menos en muchas partes de Europa y de Estados Unidos, nunca vienen con menos de un 30% de contaminación. Entonces, no se puede pensar que en la fuente, a nivel comercial o a nivel residencial, la separación de orgánicos es una solución de 100%. Es decir, siempre hay que tratar esto para separar plásticos, etcétera, porque siempre hay contaminación. Claro, hay menos contaminación que en los desechos sólidos. En los desechos sólidos típicamente hay 30-40% de orgánicos y el resto es contaminación. Y el objetivo de Energía ha sido desarrollar tecnologías que puedan tratar y extraer orgánicos de cualquiera de estas fuentes, de cualquiera de estos desechos, sin preocuparse por el nivel de contaminación. Es decir, no podemos decir, bueno, desgraciadamente está muy contaminado y no puedo extraer los orgánicos, porque si nos vamos por ese lado, entonces estos orgánicos terminan en un relleno sanitario, generando gases de invernadero. Entonces es crítico para nosotros extraerlos y luego pulirlos para poder digerir en una planta. El tipo de tecnología que utilizamos es OREX. OREX significa Organics Extrusion y es una prensa hidráulica de alta capacidad. Tenemos diferentes capacidades, desde 10 toneladas por hora hasta 40 toneladas por hora. Podría procesar la basura así como llega, pero la idea es que hay que separar primero cartón, etcétera, cosas que simplemente no van a generar energía. Entonces es mucho mejor separarlas primero con tamices vastos y luego la fracción que pasó esos tamices va a estas prensas. Y ustedes pueden ver aquí el lodo que generamos. En este caso, eso es en el norte de California y está yendo a una planta de tratamiento. Este es el camión llevando los orgánicos que extraímos de la basura y está depositándolos en una planta muy grande de tratamiento en Oakland, donde lo van a pulir y a codigerir con sus lodos. Esta es una de nuestras máquinas instalada también en el norte de California, en el área de la bahía. Este es un OREX 500, de alrededor de 20 toneladas por hora de capacidad. En nuestro próximo slide, veamos. Mi próximo slide. Perdón.
No estamos viendo nada, Juan.
No se ve.
Okay.
Ahora sí.
Ahora se ven todos los slides.
Sí,
están todos los slides.
Perfecto.
Y poner en modo presentación.
The slideshow.
Desgraciadamente lo muestra en otra pantalla a la que desgraciadamente se me está dificultando el acceso. Así que lo que voy a hacer es ir. Ahora vamos a hablar del pulimento. Del pulimento de este material orgánico que se separó con OREX. No se puede, como ustedes ven aquí, hay todavía plásticos, hay pedazos pequeños de vidrio, etcétera. Entonces, este material no está listo para ser enviado a un digestor. Para remover plásticos y alcanzamos 0.1% de plásticos de más de 2 milímetros de dimensión o en base seca, y también removemos material sedimentable, arenas, vidrios, etc. Típicamente estos son los residuales que sacamos del pulidor, y este es el material limpio que va a las plantas de digestión. En el próximo slide, ustedes ven aquí, por ejemplo, este es el material, estos desechos orgánicos comerciales, así es como se llaman estos. Esto es una planta en el norte de California, y esto lo alimentamos a nuestro proceso, y lo que producimos son este tipo de slurries, de líquidos de alrededor de 12% de sólidos, que los mandamos para codigerir con sus digestores de lodos. Esta es típicamente la calidad que producimos. Ahora me voy a enfocar a la tecnología omnívoro, que es una tecnología para digestión de altos sólidos, tanto para lodos en plantas de tratamiento como la codigestión de la que hablé, es decir, traer material orgánico externo para codigerir con los lodos en la planta de tratamiento.
Perdón, Juan, tenemos los últimos 5 minutos, por favor. Gracias.
Perfecto. Básicamente el concepto es que con espesamiento recuperativo, que se los voy a mostrar enseguida, podemos incrementar la capacidad de los digestores de 2 a 3 veces en comparación con digestores convencionales y reducir el costo de construcción. Básicamente, la manera en que lo hacemos es utilizando un espesador, un thickener, que nosotros manufacturamos también y utilizando mezcladores de altos sólidos. Y de esa manera convertimos digestores existentes en digestores de altos sólidos. Aquí ustedes ven el tipo de mezcladores que utilizamos y las cajas de servicio para acceder a los mezcladores. Luego les muestro en este slide los tipos de separación que hacemos. Estos son nuestros espesadores. Ustedes ven aquí el líquido saliendo y este material lo retornamos a los digestores, o podemos hacer espesamiento antes de la digestión para mandar sólidos en lugar de agua a los digestores. Típicamente esto reduce el costo de digestores municipales y facilita la codigestión con material externo. Luego, en el área industrial, típicamente nosotros utilizamos esta misma tecnología para efluentes líquidos, y la idea aquí es básicamente, en lugar de utilizar lodos granulares, UASPs, etcétera, cuando tienen los efluentes industriales, sólidos suspendidos altos y grasas, etcétera, hay que hacer pretratamiento. En nuestro caso, nosotros evitamos hacer pretratamiento. Cuando se utiliza lodos granulares, nosotros evitamos hacer pretratamiento y simplemente digerimos todo junto y luego desacoplamos el tiempo de retención hidráulica y el tiempo de retención de sólidos con estos espesadores recuperativos. Y eso tiene varias ventajas en cuanto a costo en general, porque no tenemos que separar y hacer tratamiento por separado de los sólidos. Voy a enfocarme en algunas de las plantas, mostrarles algunas de las plantas. Este es el espesamiento recuperativo que utilizamos, y voy a terminar la presentación mostrando algunas referencias. Por ejemplo, tenemos la planta de Sterksel, una planta que ahora ya está en arranque en Holanda, una planta muy grande que hace biometano para inyección en la red a partir de estiércol de cerdos, desechos de comida y grass silage, es básicamente pasto ensilado. Y aquí ustedes ven nuestros sistemas de conversión de biogás a biometano. Otra planta interesante es en Toronto, donde tenemos esta planta. Los dueños son la ciudad de Toronto, y en esta planta utilizamos nuestras prensas, como ven aquí, para separar orgánicos de desechos de comida residenciales y comerciales. Y aquí también se está ahora instalando un sistema de producción de biometano. Esta es nuestra planta en Limassol, en Chipre, donde manejamos alrededor de 500 toneladas al día de desechos sólidos y generamos biogás y efluente de alta calidad. Una planta muy grande en Rialto, en California. Esta planta procesa 700 toneladas de desechos orgánicos al día y 300 toneladas de cake, de plantas de tratamiento municipales de aguas negras, y nosotros secamos y hacemos pirólisis de ese cake seco, y utilizamos la energía de la pirólisis para secar el material. Esta planta está en operación. Aquí ustedes ven, estos son quizá los digestores más grandes que hemos construido tienen 14.000 metros cúbicos cada uno. Y finalmente, otras plantas donde hemos hecho lo mismo, estas son plantas de codigestión, donde hemos hecho conversiones a digestores existentes aplicando la tecnología Omnivore. Una planta muy grande en New Jersey, que ahora ya está en operación, donde convertimos unos tanques existentes para almacenamiento de lodos, los convertimos en digestores. Aquí tienen ya la planta en operación. Esta planta genera 3.8 megavatios de electricidad. Nosotros hicimos toda esta instalación. Aquí tienen ustedes los motores, el almacenamiento de gas y los tanques convertidos a digestores de alta capacidad. Y finalmente, en efluentes industriales, es una planta en Sudáfrica, donde una planta industrial está en construcción un poco demorada por COVID, pero esta planta empezará a mediados del año siguiente. Y aquí también tenemos líquidos y tenemos sólidos de destilería utilizando uvas. Y en esta planta también vamos a generar 2 megavatios de electricidad. Es una planta industrial que trata líquidos y trata sólidos. Con esto, les agradezco mucho por su atención y estoy abierto a cualquier pregunta que ustedes tengan.
Muchas gracias, Juan José. Vamos a dar lugar a alguna sola pregunta porque ya estamos con el tiempo excedido. Gracias. Jorge Durán, si vos podés resumir alguna de las preguntas, por favor.
Gracias, Juan. Teníamos miedo de no tener preguntas, tenemos muchísimas. Pero bueno, es difícil elegir la más interesante. La primera es si, qué experiencia tienen en feedlots, que obviamente la tienen. ¿Cuál es el nivel de generación específica de energía que obtienen en feedlots?
Me imagino que esto es para ganado vacuno.
Crianza de ganado vacuno, sí.
Para crianza de ganado vacuno. Tendría la generación específica de biogás tendría que ver en nuestras tablas. Y es decir, no es que necesariamente generamos más biogás que con otros sistemas de digestión. No ese es el punto. El punto más bien es, y no tengo los números en este momento a la mano en cuanto a la generación específica de biogás, pero es típicamente lo que las tablas muestran para el tipo particular de estiércol que sería, o de desechos que sería tratado. Pero básicamente la parte interesante de nuestra tecnología es el hecho de reducir el tamaño, el volumen de los digestores, porque tenemos la capacidad de digerir a tasas más altas. Es decir, quizá la respuesta directa es no generamos necesariamente más biogás que otros tipos de digestión, pero podemos reducir el costo de los sistemas de digestión porque reducimos el tamaño de los tanques, haciendo que el desecho líquido se vaya y reteniendo los sólidos.
Muchas gracias, Juan.
Muchas gracias a ustedes.
Bien. Hacemos una última pregunta, Jorge, si es que hay. Yo sé que hay varias.
Sí, hay varias. Aquí hay una con relación al sistema OREX de procesamiento de sólidos, que evidentemente es una de las especialidades de Anaergia, y preguntan qué nivel de mantenimiento requiere este sistema.
Definitivamente hay un requerimiento de mantenimiento a las 3.000 horas, a las 6.000 horas, etc. Y hay, sobre todo, es el reemplazamiento de ciertos componentes que evidentemente se desgastan, pero en nuestra experiencia es competitivo y no es significativo o muchísimo más alto que otras tecnologías para extracción de orgánicos. De nuevo, es decir, creo que me sería difícil decir cuántos dólares por tonelada, porque es por tonelada procesada, porque eso tiene muchísimo que ver con el tipo de desechos que Lorenz esté tratando, etcétera. Si tiene más vidrio, por ejemplo, habrá más desgaste. Pero en general, la respuesta es que nosotros no hemos encontrado otra tecnología en el mercado que pueda separar de desechos sólidos de alta contaminación, que pueda separar orgánicos sin la adición excesiva de agua, y que pueda llegar a la calidad que nosotros llegamos para poder digerir. Es decir, existen otros sistemas de digestión secos, etcétera, pero que producen, donde se puede digerir con muchos contaminantes, pero eso produce, no se puede recuperar para ningún uso beneficial los residuos de ese sistema de digestión, porque están llenos de contaminantes. Entonces eso va definitivamente parcialmente digerido a los botaderos, a los rellenos sanitarios. Y con nuestros sistemas podemos extraer más orgánicos, y esos orgánicos se digieren más que cuando comparamos esto con otros sistemas de digestión seca.
Ok.
¿Hay tiempo para una más?
Una muy breve pregunta y una muy breve respuesta, por favor.
Gracias.
Bueno, acá preguntan acerca de la experiencia en granjas avícolas, y cómo se maneja el alto contenido de nitrógeno, que supongo que es amonio, ¿no es cierto?
Excelente pregunta. Tenemos experiencia, por ejemplo, en este momento tenemos una planta en Singapur con 100% de estiércol, alrededor del 25% de sólidos, y estos son de layers, es decir, de gallinas ponedoras. Pero también lo hemos hecho con broilers. Y podemos hacer digestión desde 100% de este tipo de desecho. Lo que ocurre es que tiene un gran alto contenido de nitrógeno y urea, y lo que nosotros hacemos es utilizamos un AMR, AMR, que es un sistema de stripping. Nosotros removemos la amonia del filtrado de los digestores, y luego retornamos eso, recuperamos esa amonia con un sistema de stripping y scrubbing, y luego, que es un sistema físico-químico, y luego retornamos ese líquido para diluir y remover, diluir y remover also, también grit. Hay muchísimo grit en el desecho en el estiércol de pollos, y tratamos de mantener alrededor de 3.500 miligramos por litro el amoníaco dentro del tanque, y es básicamente con dilución de los líquidos que retornamos y les extraemos el nitrógeno, la amonia, y eso lo convertimos en sulfato de amonio, que es un fertilizante que la planta vende. Es decir, esa es la respuesta. Es dilución sin aumentar agua externa, más bien recuperando la amonia del filtrado del digestato.
Bueno, muy bien.
Quedan algunas preguntas, pero irán después por escrito, entonces.
Claro.
Muchas gracias, Juan.
Bueno, vamos a agradecer, por supuesto, a Juan por el abordaje de esta problemática relacionada con la economía circular, ¿no? La recuperación de recursos. Así que vamos, para dar por concluido esta presentación de estos 6 expositores, le quiero dar la palabra a la licenciada Ana Fischer, que en nombre de la Embajada también nos brinde algunas conclusiones. Por favor, Ana, y luego hacemos el cierre también dando algunas indicaciones adicionales. Gracias.
Bueno, muchas gracias, Juan Martín. No sé si me escuchan bien.
Sí, muy bien.
Sí, bueno, aprovecho. Muy buenas tardes a todos. La idea es ser muy breve porque fue una larga mañana y ya estamos sobre la hora del almuerzo. Simplemente quería agradecer nuevamente a IDIS, al Gobierno de Ontario y a la Cámara de Comercio Bilateral por la organización de la jornada, y a los expositores por las excelentes presentaciones, y a los participantes por su interés. Ya lo dijimos muchas veces, pero bueno, les recuerdo que si los participantes están interesados en desarrollar vínculos comerciales con alguno de los panelistas, pueden escribir a la Secretaría de AIDIS. También les quería comentar que desde la Embajada de Canadá en Buenos Aires y las embajadas de Canadá en otros países de Latinoamérica, vamos a seguir esta línea de trabajo para dar a conocer más tecnologías limpias y acercar empresas canadienses innovadoras a nuestros mercados. Y esperamos, por supuesto, reencontrarlos en torno al Congreso Interamericano de AIDIS en el mes de abril de 2021. Y para cerrar, algo aparte, me gustaría recordar que hoy, 11 de noviembre, es el aniversario del armisticio de la Primera Guerra Mundial. Es una fecha muy importante en Canadá y en otros países del Commonwealth, y estamos conmemorando lo que llamamos el Remembrance Day o Poppy Day, Día de la Amapola, en honor a los caídos en los conflictos armados y a los veteranos de guerra a partir de la Primera Guerra Mundial. Bueno, como es tan importante, quería hacer el hincapié en esta fecha particular. Eso es todo, les agradezco mucho la participación y bueno, que tengan una muy buena tarde.
Muchas gracias, Ana. Un justo reconocimiento a todos los caídos en estas conflagraciones mundiales, así que muchísimas gracias por recordárnoslo. Entonces, para ir cerrando, como bien decía Ana, agradecimiento inicial a todos los expositores. Han realizado unas excelentes exposiciones, obviamente a la Embajada de Canadá y al Gobierno de Ontario por esta iniciativa que, como decía nuestro presidente de AIDIS, han confiado en nosotros para asistir también en esta parte técnica. Y esperemos que, bueno, esto pueda prosperar en futuras rondas de negociaciones, vínculos comerciales, que nuevamente reiteramos, para quienes no han podido tomar nota, deberían hacerlo. El canal de vinculación para establecer estos vínculos comerciales sería a través de AIDIS, a través del correo electrónico secretaria@aidisar.org.ar. Esperamos también, como bien decía Ana, que estas empresas y algunas otras también del Canadá puedan participar en nuestro futuro Congreso Interamericano de AIDIS, que se va a desarrollar en abril del año que viene. Y finalmente reiterarle que algunas de las preguntas, como por falta de tiempo no la hemos podido formular, serán respondidas, por supuesto, por escrito, ¿sí? Y recordándole finalmente que esto también en los próximos días, toda la grabación de todo el evento será puesto en las redes sociales, tanto de AIDIS como de la Embajada de Canadá, de modo que yo no tengo más que agradecer a todos los participantes también su atención, su paciencia. Ha sido una jornada muy larga y creo que ha sido una jornada muy productiva. Les agradezco mucho y nos veremos pronto. Muchísimas gracias a todos por este evento. Muchas gracias. Hasta luego.
Thank you.
Gracias.